Mumbai ground, Victor Tango, Victor Golf Papa, request time check.
Victor Tango, Victor Golf Papa, Mumbai ground. Time now 0901.
Time now 0901. Victor Tango, Victor Golf Papa.
Vishnu, what did we speak about? I need energy in your calls. Where is that energy? I cannot hear that energy. When will you try to put some energy in the call, if not now? It takes conscious effort to put that energy. You just need to make sure that, okay, yeah, I have some energy. You have to just remind yourself about it. Vishnu, no acknowledgement?
Yes, sir. I'm trying.
No, but whatever I've said, I need an acknowledgement before you try, right? Dead air 5 seconds. Come on. It's basic conversation rule, dead air 5 seconds. It's a basic conversation rule. It's not just anything. It's just that whenever you're conversing with anyone under the RT environment, you have to make sure that you respond. You have to make sure that you respond within 5 to 10 seconds. Simple. No matter what is said, no matter what you're thinking, you have to respond. It means you can say even Roger. Roger means I have received and understood your message. It's equivalent to okay. It doesn't mean a yes or a no. So something like that. Be very mindful about these little things, students. Let's settle down, everyone. Just giving a couple of minutes to for everyone to join. I think it's the weekend. We're not going to have many students in class. I am not sure. Please revise what we had done in the last class. See if you have any questions. These are technical topics. These are having wide applications everywhere in the field of commercial pilot. Check what are frequencies. Check what is wavelength, the table, the applications. There's a lot of data given to you. See if you have any doubts. No questions, anyone? See, take a few minutes, nicely revise, go through all the points, see if you are able to speak about these points in your own words. Okay. Students, you don't have to ask to practice a call. Students, why are you not remembering the instructions given to you all? The first 5-10 minutes are for you to practice calls, for you to ask questions and doubts. So why do you need to ask if you can practice a call? You are required to practice a call. Come on. No questions, students. I'm giving you 5 more minutes. Do thorough revision. We are going to cover a lot of more important points, but we are going to cover it in short. Sajal, if you want to take a call, quickly take a call. We only have first 5 to 10 minutes. Don't wait. Something that I've told you all already, never wait to practice a call. The channel, whenever it is quiet, you just go ahead with your call.
Mumbai ground, Victor Tango, Sierra Juliet Lima, stand 2, Airbus 320, moderate, IFR, Mumbai, to Delhi. Passengers on board 150. Security check clear. Information Charlie. Request pushback and startup.
Victor Tango Sierra Juliet Lima, Mumbai ground. Startup not approved. Tow truck is still attached.
Startup not approved. Tow truck still attached. Will move and call again. Victor Tango Sierra Juliet Lima.
Roger, Mumbai ground. See, Sajal, you are not asked to go to the next question. So
Yes, sir.
apparently you have to continue the call.
Okay. Mumbai ground. Victor Tango Sierra Juliet Lima. Stand 2. Tow truck remove. Request pushback and startup.
Victor Tango Sierra Juliet Lima. Pushback and startup not approved. Mumbai ground.
Pushback and startup not approved. Request reason. Victor Tango Sierra Juliet Lima.
Victor Tango Sierra Juliet Lima, Mumbai ground. Startup not approved due bad weather.
Startup not approved due bad weather. Will call again once weather improves. Victor Tango Sierra Juliet Lima.
Very good. Vishnu and Sajal, good calls. I'm very happy. Sajal, very nice. See, students, you don't have to ask. You can always practice calls, but you can ask and also practice calls. No problem there also. Very nice, Sajal. But I appreciate in the first minutes if you could take your calls on your own. Now, Sajal, very good. I could say it's a rally between you and me. Very good way to do it. Very nicely said. No problem. Everything is superb. Very, very good. Only thing that I was trying to test you further and further. You have done nothing wrong, okay? It's just that I was trying to test you further and further and see if you would request for a special VFR asking about RVR. When I've informed you that it's bad weather, but I didn't say anything. So if it's bad weather, you can request for RVR. If the RVR is above 1500 meters, then you can request for a special VFR. Even though your aircraft flight plan talks about IFR, it's just a simulation that you have to do in the exam for calls. So you could do that RVR and special VFR also. If the RVR would have been lesser than 1500, then you would have said, we'll wait for weather to improve. That was correctly said. Also make sure that with respect to startup and pushback calls, make sure you read other information also. It could have anything to do with priority where you are not supposed to take delay unless weather is so bad that you cannot take off. So you have to be a little careful over there also that if startup and pushback calls now, right now in this situation, we were not assuming any other information or priority handling or special handling. But in case there are startup pushback calls, then probably such information would be there somewhere in other information. Other information can be considered as the final point in your exam flight plan. So the exam flight plan has 13 points. The actual ICAO flight plan we have studied in detail, right? So make sure for your part 2 Viva, you'll also remember the iCATS flight plan also thoroughly. Yes. Very good, Sajal. Very nice. How was the experience, Sajal?
Sir, it was good. Initially, I thought in the last part what to say, but finally, I got the idea.
Very nice. Very nice. Students, if you make a few mistakes in the exam, but overall, if your quality is good, then that is not going to impact your results. Understand. What do I mean by quality? Now, Vishnu's call, Sajal's call, they are good quality calls, we could say. Comparing Vishnu and Sajal's call, I would say that Sajal's call sounded more energetic compared to Vishnu's call. That's the only difference I could find. Otherwise, everything is superbly clear. That's it. So Vishnu is being told to try to increase that energy. Now that energy, even if Vishnu doesn't increase, it's not going to impact his examination performance or his results. Okay. Understand that clearly, Vishnu. Even if you're unable to bring these little extra things in the end, like energy and urgency in your tone and all, even if you cannot bring it, the examiners understand where you're coming from. And if the quality is good, which is for your calls, then you'll get the benefit of doubt in case things go south. Understand what I'm saying. Why do you think you will not clear in part 1 when things go south? When I say things go south, something or anything could go wrong that you have not planned. Maybe you miss out a question, maybe you read it wrongly, maybe you say a wrong call sign, maybe you call wrong ATC, maybe you just are so anxious and so nervous that you just get stuck or zoned out, or maybe the examiner is not focused enough to help you pass. Those are the primary reasons why you will not clear in your first attempt. Okay, those can differentiate. Now, what is the difference between those things and your preparation? So if something goes wrong where you're not able to perform optimum, if you make mistakes, this and that, which is bound to happen in your first attempt because it will be a first time experience. Everybody makes mistakes. So we try to reduce those mistakes that you'll be making in the first attempt right now here, so that your first attempt is clean. Why do you think RT people have to give 3 to 4 attempts? Because they make mistakes in their first few attempts. Eventually, they realize by themselves that they have to avoid those mistakes. And why are we making mistakes? Because there is a gap in our knowledge. Somewhere or the other, we are not able to grasp everything, not able to remember everything, not able to recollect everything. So again, it's not your fault, but it's your responsibility, which will come to you with patience and time. So you need to have that maturity also. All right. These little things will really help you if things go south and still ensure that you'll clear in your part 1. All right, students. So make sure you follow this, try these, and try to have a little change every time that you do the call. Very nice. And trust me, if your calls are so clean like Vishnu and Sajal is taking right now, then even if you make some mistakes here and there, you'll still end up clearing part 1 nicely. Provided your total score is at a level of 60 to 70% minimum. So that ensures quality. So you target 70 only in RT minimum initially. Passing is 50, but that doesn't guarantee good quality. So remember that, okay? Good students, let's get started with the topic for today. Now, understand. Once again. Harsim is not here, right? Sahil is here. Very good. So Sahil, after Vishnu, you are next. Your exam is on 30th. Okay. And students who have not given me their dates, please make sure you all give me your dates also. I'll just read your dates again once. Confirm if everything is right or if I've missed someone. So Vishnu 22nd, Sahil and Harsim are doing on 30th. Okay. Sajal, you're on 6th. Anyone between 30th and 6th not informed, please let me know. Okay. Anyone? All right, good. After Sajal, we have Tripti. Now we know Tripti is busy working. People from evening batches, I think Priyam, you remember her. So she will also be giving 7th, but she basically maintenance students are highly occupied at their jobs, you know. They work 14-hour shifts, 6 days, 7 days a week. It's very difficult. Then 8th is Priyam, right, Priyam? Anyone in between 6th, 7th, 8th that I have forgotten or missed, please let me know. Then 9th, nobody has. People on 9th, I think your exams got postponed, a few of them. 10th is Sharad and Nukul, right? 10th is Sharad and Nukul. Anyone that I have missed between that, let me know. So Sharad, please don't panic. I can sense you are panicking. And I think you are taking part 2 very lightly. Don't do that. Right now, what we are doing is we are preparing you for part 2 also. It is equally important for part 1. Right now, just put your focus there because that's the time that we have to do. It doesn't mean we'll not do part 1. You might be thinking, sir, part 2 khatam kara ke chale jayenge. No, it's going to go on and on, individually tailored to you also. And अभी तक तो नुकुल से तो बात भी नहीं हुई अभी तक 1-on-1. आपसे तो फिर भी हो गई है. सजल से अब तक बात नहीं हुई है. प्लस साहिल एंड हरसिम से अब तक बात नहीं हुई है. उनके एग्जाम तो 30th को है. आपसे इसलिए बात हुई है क्योंकि आपने लेक्चर्स अच्छे से अटेंड नहीं किए हैं. सो वहां पे एक फेटल एरर था विच यू डिडंट नो. ओके, सो आप एग्जाम में सरप्राइज हो जाते फिर. समझ रहे हो? सो वो उसको उतना ही टाइम लगेगा जितना टाइम लगना चाहिए. सो डोंट पैनिक, बट वॉट एवर यू नीड, यू कीप लेटिंग मी नो द वे you are letting me know. But please follow instructions properly and keep letting me know. But do not be stretched in between two things thinking, my part 1 is not done, part 1 is not done, part 1 is not done. Understand, 4 days of part 2 might not be enough for some of you. It has to be enough for Vishnu because that's the only time we have to make do with it. So we go with a positive attitude. But others, it's not going to be end for you. I'm going to teach you more things. It's going to be like that. Okay. So there are a few topics from radio regulations that we have not covered. We'll be covering it again. Continuing Monday, Tuesday, Wednesday. We have 3 more lectures, right? We have to dedicate it for part 2. So others will be noting down more points. And whatever will be left, we will be doing a complete overview of that. And by Wednesday, we are planning to complete everything about your part 2 nicely, thoroughly. So then mentally you're prepared and you have something to self-study in the long run. And once that is done, then you all can nicely, smoothly work on your part 1 and simultaneously keep studying part 2 in your free time. Isn't that a good idea? Get the monkey off your back. Otherwise, in the end, what happens, I'll tell you, students end up clearing part 1, but they don't get through part 2 because of lack of experience, lack of practice, lack of knowledge, because it becomes too much to remember it in the last 2 days. It's not a theory exam that you get 50 and you will pass. It's Viva. It also depends upon a lot of things. Got it, students? So Sahil and Harsim, please get in touch with me and schedule your sessions one-on-one. And in line would be Sajal. Basically, Hardik also has his exam on 3rd. I miss. Hardik is not there today. Probably he's not feeling well. I think he's stressed. So Hardik is on 3rd. So see, the sequence has to be followed. Otherwise, someone or the other can be missed out. But I'll make sure nobody is missed out, okay? So please understand. After Sharad and Nukul on 10th, Nukul, we have to practice one-on-ones, okay? We have Karan on 12th. Karan on 12th, is that correct, Karan? Let me know. And then 13th we don't have. 14th we have Sharvari and Pooja. Let me know if it's correct, students. 15, 16, no one. And then 17 we have Jyotsna. Have I missed anyone? If I've missed anyone, please let me know. Okay? So yeah, whoever needs anything in addition, please feel free to share with me like Sharad does, Vishnu does, like Sajal was asking. You have every right to do so as many times as you want. Okay, no problem. But then also follow the instructions. And if you don't like my instructions or you cannot comply with them, then tell me, sir, I don't think it's a good plan. Can you give me a better plan? Then I'll give you a better plan or I'll explain why I think this is a good plan. You should be convinced. If you're not convinced about something, then don't do that. Tell me. I'll give you a better idea, okay? Got it, students? Let's start with our class. Today's, I'm thinking of not overloading you all today. So we'll start with propagation of radio waves. We're going to make it very simple. Generally, the lecture could go about 2 hours just discussing propagation, minimum, covering minimum basics, but we'll try to wrap it up within half an hour. That is also too much. Why? Because in the examination, you'll hardly get 3 to 4 minutes. Hardly you'll get 30 seconds to 1 minute to discuss about entirety of propagation of radio waves or a part of it that they'll ask you about. So why not just study with that perspective in mind, right? that, okay, we just need to learn this much right now, so let's do it this much. But remember, to get more idea and learn in depth, you can always do further reading whenever you have time. So it doesn't mean this is the max that you'll study. This is the minimum that you'll study. And remember, 100%, whatever I'm giving you, over and above, whatever you learn can help you. Got it, students? If you don't have the material, you can ask me and I'll send you the material. All right. So propagation of radio waves is very simple. I'm going to make it in a very simple flow chart. You have to understand. Otherwise, you will be always confused because different books use different terms and it's never clear actually which wave is which wave, what propagation is actually what propagation, although there are only 3 to 4 elements involved. So why is that confusion? Even we as students had this confusion for a very long time at a young age because we didn't get proper instruction, but then we figured out and then we were like, okay, fine. Now we know everything. Good. It really makes us satisfied when we clear all our doubts, you know. So, yes, propagation of radio wave. Who can tell me what is propagation? What do you mean by propagation?
Sir, conduction or traveling of radio wave. The way
And your answers with your call sign, students?
Victor Tango Papa Romeo Mike.
Yes. You can say how radio waves travel through the atmosphere. Propagation is how radio waves travel through the atmosphere. Okay. So let's get started with the simple definition to understand. Otherwise, again, we'll be like, okay, what's happening? Before that, I just one question, sir. RVR would be available on DATIS or we have to ask ATC? Of course, RVR will be available on DATIS, Automatic Terminal Information Service. But maybe the data must have been updated and the DATIS code might not have been updated. So you can ask ATC. Generally, you can ask ATC wherever you don't have DATIS also. But understand, sometimes a call can just be simulated just so that you get an extra point in that call. So you can ask ATC also if you're not clear with the DATIS information. But wherever DATIS, that is your first point of first source of information. Okay, so Ayush, Nukul, welcome. Nice to see you all. Vishnu, Sahana, Sajal, Priyam, nice to see you all. And Sana, nice to see you. Attend regularly your initial lectures. Initially, it can get difficult, but very nice. Generally, we go slow initially. For you, it's been back to back. Nice to see you. Keep up. Sajal is back. Sahil, nice to see you with your dedication. I'm sure your hard work is going to help you all students. Pooja, welcome. Jyotsna, good morning. Welcome. Sharad, I hope you're keeping well. Karan, nice to see you attend lectures. I hope you're learning and doubts are being sorted. Rishi, welcome. And Anwar, welcome. I hope you're feeling well. Hardik's not there. Neha's not there. Anchal's not there. So many students are not there today. Vignesh is not there. Second Vignesh is not there. So many students are not there. This Pratik also. And Sharvi also. Sushma also. But good of you all to make it. I'm sure they'll be following it up some or the other way. So what is propagation? Propagation is, write down. Write down. Propagation. How radio waves of different frequency bands and wavelengths travel in the atmosphere for transmission and reception. Yeah, right. Propagation of radio waves. So what is propagation of radio waves, students? Simple. It is how the radio waves of different frequency bands and wavelengths travel in the atmosphere for transmission and reception. Easy? Anyone confused about it? Easy, right? Question number 1. Radio waves, how do they travel? Now, they can simply ask you this question in this simple word, how do they travel? Or what they can do is they can simply say, talk about propagation of radio waves. Or they can say, what do you know about propagation of radio waves? Or they can simply say, how does low frequency propagate? How does medium frequency propagate? How does high frequency propagate? How does very high frequency propagate? And so on. Or they could ask you little pointers from these methods of propagation. So basically, anything and everything could be asked, or nothing could be asked, or something could be asked. Got it, students? So you need to be aware that you understand the point in one and then be ready for whatsoever answers you have. So focus on the answer carefully. And whenever an answer is question is given to you, before giving the answer, think about the answer and note a mistake that you could have been you could be making in your mind, and then go ahead with your call or answer. The same strategy you have to apply in your part 1 also. Every major question, question number 1 or 1 alpha, 1 bravo or 2, every question should be a fresh question where you'll frame the call in your mind first to figure out mistakes and then do a live call. The 5-second rule or a 10-second rule of acknowledgement doesn't apply to new questions. That rule only applies to a question that is ongoing with calls between you and ATC. A hot conversation, a live conversation. That's where acknowledgement should be given within 5 to 10 seconds. Otherwise, the other person gets scared thinking, what happened? Where did you go? It sounds rude, as well as we think that what happened to you? Did you just, lose communications, or did something happen to your aircraft? So that's why it's very important that we acknowledge within 5 to 10 seconds. Ideally, that's the safe response time. If everybody responds within 10 seconds, then we understand everything is fine. If there is a delay more than 10 seconds, then we understand that pilot is occupied with more than normal situations. So that's why you have to ensure, no matter what, you simulate a normal situation by making sure 5 seconds. If you stick with 5 seconds, then sometimes you might have a delay on a bad day and go with 6 seconds, 7 seconds, 8 seconds gap. That is still safe, because by law of radio telephony manuals, the rule is to reply or acknowledge within 10 seconds. But we practice 5 seconds to have that buffer. Got it, students? Otherwise, if I make you practice 10 seconds, then on a bad day, if you give 15 seconds, then that would be a lag. Examiner can deduct points on that. So radio waves, how do they travel? Different frequency bands travel differently. Low frequency and medium frequency generally travel via surface waves. Surface waves are low energy propagation method where radio waves travel to a distance following the curvature of the Earth. Any obstructions in path can cause the wave to bend and turn around it, or can also be slowly reduced in energy as distance increases. Now, what am I talking about in these 3 points? Subpoint number 1. LF and MF generally travel via surface waves. What are surface waves? They are low energy waves or low energy propagation method. Why low energy? Because LF, MF we know are low energy radio waves, low frequency. High frequency will have higher energy compared to low frequency. Remember, frequency or vibrations give the radio waves their energy, not the wavelength. Wavelength will only give the range. The question here is that not many people will refer the word energy again and again with your radio waves, but it is for your better understanding what is happening. Okay. So surface waves are low energy propagation method where radio waves travel to a distance following the curvature of the earth. So how does it look like? So this, if you're wondering what this triangle is, then this looks like that bigger antennas that we have, or those poles on which our electrical wires are, there. So this represents an antenna. This for our examples, we call it TX as in transmitter. So how is a surface wave? A surface wave goes like this, following the surface of the curvature of the earth like this. And then it will lose its power over certain distance as the distance from the transmitter increases, and it will just disappear over here. It has limited range. Okay. Plus, if it has certain mountains in between, let's say some mountain like this, then what will happen? The radio wave can either curve around the mountain like this and then further go diminished, or sometimes can also be blocked if the obstructions are too high or too heavy. So LF-MF is not too dependable. But what did we learn about LF-MF? The range of surface waves is more over sea than land. Of course, now sea areas will not have any obstructions, right? One basic funda. Plus sea and land, sea gives more range to LF and MF frequency bands because we saw the formula. So remember, you have to relate the formula of range also in this part. Surface waves, the range formula over sea 3 into square root of power in watts, and over land 2 into square root of power in watts. Got it? So I'm not giving that in writing here. You can add it. So this is a surface wave. Now, HF also travels as a surface wave. Okay. HF also has the capacity to travel as a surface wave. But then we already know there are limitations with surface waves. The clarity will be also lost because of obstructions. And we cannot always have C to give longer ranges. We have to also transmit over huge masses of land also. So HF can also travel as a surface wave. Write this point. HF is one such frequency or frequency band, you could say, that can propagate via surface waves as well as sky waves. Okay. Next point you will write. Surface waves do not require ionosphere for propagation. That is, surface wave is non-ionospheric propagation. So same thing, but different terms. Some people will ask you to differentiate propagation between ionospheric and non-ionospheric propagation. So it doesn't require ionosphere. Ionosphere is one layer of the atmosphere, a little higher layer of the atmosphere, where we have a lot of activity of ions. Ions are electrically charged particles. Under the influence of the sun, they get activated. When the sun is not there, then the activation levels are low. So what happens when they are activated? They rise up in the air So the ionosphere during the daytime goes a little up. During nighttime, because there is no sun, they are not that highly activated. So the layer of ionosphere comes down. So this is something that is related to ionospheric propagation that we'll discuss. So surface waves, generally LF and MF are preferred mode, while HF can also transmit it, but that is not a preferred mode. So you'll write down for LF and MF, surface wave is preferred mode. For HF, surface wave is not preferred, but sky wave is preferred. Now you will be surprised. Many students don't know this. Many students they miss out on this point that HF can be used to transmit in both ways, or HF can transmit or propagate via both. This point is missed by a lot of students, because of which they don't understand ionospheric propagation or skywave propagation, which is the most important propagation to learn for us, HF. So you have to understand HF can propagate via 2. Got it, students? But we don't use surface wave, we use sky wave. Got it? So number 2, you will write HF propagates via sky waves. So we spoke about surface waves, that much is enough. Now we'll talk about sky waves. Now remember, whenever there is propagation, there will be errors related to propagation. Errors would be like attenuation, fading, okay, and a lot of other terms. On them, I'm going to give you a written document for you all to read, okay, so that at least you know something instead of nothing. So surface wave will have certain errors, sky waves can have certain errors, okay, and generally also radio waves will have certain errors, that is loss in the strength of the signal or loss in intelligence. So HF propagates via sky waves. Number 1 was LF and MF. Now we are covering HF. So you see, we are not talking about VLF. Why are we not talking about VLF? Generally because it doesn't have any application in aviation. If VLF had to be transmitted, then again it would be transmitted via surface wave only, ideally, but the range would further be reduced. Okay. Now you all already know sky waves, right? Yesterday I had shown a diagram. Okay. So first point you will write, sky wave propagation is also called as ionospheric propagation. Second point, it is dependent on ionospheric refraction, also called as total internal refraction of the HF wave by the ionosphere when the HF is transmitted at or above the critical angle. Now this is, so skywave propagation or HF is the only propagation that has 3 to 4 individual terms that are hot topics for question and answers all along your CPL journey. Okay. So that's why this is important for us, not just RT, but everywhere else also. I'm going to make it very simple. If you are confused, please ask. Ionosphere, when by the ionosphere, when the HF is transmitted at or above the critical angle. critical angle. It's the first angle between the normal of the transmitter and I'll show you what the normal looks like. It's just a perpendicular line. Critical angle, it's the first angle between the normal of the transmitter and the transmitted HF ray, which returns back to Earth after total internal refraction from the ionosphere. Now, this is a sentence that we have constructed in our own words. We'll simplify the same sentence again in a different sentence. Okay. Critical angle is the first angle between the normal of the transmitter and the transmitted HF ray, which returns back to the Earth. So it is the first angle between the normal of the transmitter and the transmitted HF ray. The ray which returns back to the Earth after total internal refraction from the ionosphere. Or critical angle is the angle at which the critical ray or the first sky wave is the angle at which the critical ray or the first sky wave to return back or the first sky wave to return back. So critical angle is the angle at which the critical ray or the first sky wave to return back is transmitted. Now you'll write critical ray. It is the first sky wave to return back at an angle called as critical angle, like this. So it's interconnected. You will write note critical angle can also be called as the minimum angle to maintain between HF radio wave to be transmitted and the normal of the antenna. So how does this look like? Again, this is our antenna, TX. Let's assume HF via ground waves or surface waves. Surface waves can also be called as ground waves, okay? So this is HF via surface wave going up to only here. Not enough for me. I want to see if I can increase the range. So I get an ionosphere, okay? It will be helpful if you could remember a little bit about ionosphere also, like what is the height of the layer, approximate height of the layer. It comes later. It comes after troposphere, stratosphere, okay? So let's say that this is the ionosphere. And this ionosphere also has layers, okay? This ionosphere in itself is also divided between different layers. So like I said, the topic is very extensive. But it's okay for RT to cover up the basics, one by one. First the basics, then anything else is good for you. Now what happens? What is the normal? I'll make the normal in green. So perpendicular to the ground like this properly. So making a 90-degree angle, this is the normal for the antenna. Okay. Now what happens? I'll show you your HF ray in blue. If this is the wave I'm transmitting, it is escaping. If this is the ray I'm transmitting, it is escaping. If this is the ray I'm transmitting, it is escaping. So scientists, they will try to transmit the radio signal at every angle possible to see when is the first reception coming up. Whenever the first reception comes, that angle is fixed as a critical angle. So we make sure that anybody else who wants to transmit, like HF is used by FICs, Flight Information Centers of FIR regions, right? Flight Information Regions. So their hardware or the antenna and everything will be set up in such a way that all radio waves are transmitted at least at this particular minimum critical angle. How do they figure it out? They try all angles. The first angle to send back a radio wave would be the critical angle. So all the angles would be more than that only. More than that, because you're comparing the angle between this and this, like this, and not with the surface of the earth. So the angle just keeps increasing. Got it? That's why we say it's the minimum angle. So let's say the fourth wave that I have transmitted actually was returned back like this. Let's say like this. So this is the first ray to return. A ray is one single ray of signal, we can say. So if this is the first ray, then in red I'll make this angle is equal to critical angle. Got it? This angle over here. And this ray is called critical ray. Now, these are these technical terms related to your propagation that are extensively asked everywhere. Okay. Now you see this is HF via sky wave. So this is called sky wave. Why? Because it's going over and above the sky limits, general limits where we fly. Ionosphere is way too high. It's not like 30,000-40,000 feet. It's way too high. It's in hundreds of kilometers. So this is a sky wave. So HF via sky wave is this, and HF via surface wave or ground wave is this. Okay. Now the difference between where the HF as a surface wave ends, the distance or the difference. So this is the point where my HF surface wave ends. So the distance between the point where my HF surface wave ends and the point where my first critical ray is received, this point, this distance D, this distance is called as dead space. Another very important and obvious question related to radio wave propagation. Now, many students are unable to remember dead space. Why? Because they fail to realize that the dead space is basically the space which we would have not got any signal, or it is that space where we are not getting any HF signal. Now, what is the meaning? The meaning is that even though I'm radiating as a sky wave to make sure I get high range, chances are a portion of the HF transmission would automatically be transmitted as a surface wave also. So that way it will give you a lot of reception. HF will give you reception. HF will give you reception over here also. Plus it will give you reception everywhere wherever the receiver or the critical ray is reaching. The only place you will not get the reception would be this little area over here. That is the dead space. Got it, students? But in the exams, it would be enough for you to say that dead space is the difference between the point where surface wave of an HF signal ends and the distance between the point from this point to the point where the first sky wave is received. That area where no signal of HF is received is called dead space. But then generally, HF is such that it is wholesome. But this dead space is calculated and arrangements are made for it so that HF can be received at a wide range of distances, basically. Okay, so write down dead space, and the other thing would be skip distance. The distance between this and this distance, D2 will say, this distance, D2 just for our reference because D1 was dead space. This is called as skip distance. So how much distance is the wave traveling in one skip? It is called one skip. Okay? Or hop, you can say. One hop. And remember, there are multi-hop also. The waves can further get reflected, further go back, and further get internally refracted, giving us multi-hop. Okay? These are the basic elements of your ionospheric propagation or skywave propagation or HF propagation. All three are the same things. Now, students also get confused thinking the three things are different things. Skywave, ionospheric, HF. All three are the same thing for us. HF can also transmit via surface waves, but that we don't really use that way. Now note, couple of important points. Note, during day, ionosphere is higher. During night, ionosphere is lower. Thus, HF frequencies used during day will not be of use at night. Therefore, for a same air traffic, for the same air traffic controller over HF, you will have to use separate HF frequency during day and separate HF frequency during night. So remember, even if you're speaking to, let's say, HF Mumbai radio, then Mumbai radio, in the morning, you'll connect with Mumbai radio on a separate frequency on HF. During night, same flight plan, everything same, just the time of day is different and turned to night. Then you'll be talking to the same radio on a different frequency. As a rule, during night, the frequencies of day are reduced by almost half. That is, as sun comes down, frequency comes down. Simple. Sun goes up, frequency goes up. Sun goes down, frequency comes down. Frequency. So a simple, the conclusion of this answer would be that during nighttime, we use half of the frequency that we use during daytime on HF communications or HF transmissions and receptions. That is, during day, we use almost double the frequency compared to that of night. And in other words, during night, we use about half of the frequency used during day. Got it, students? Now see, whatever I'm teaching you, basics, the benefit of this right now is that even if I give you certain material to read, you can read and understand everything because your basics are clear. Whenever you'll be reading, whenever I'll be sending anything, make sure you read at least once or you follow the instructions either given verbally or given in the email. Don't think, Array, I won't want to do it on my own, I won't understand. It's not like that. You have been trained to understand it even if you do it on your own. Just read, and whenever you are stuck anywhere, if you cannot make sense, then share that doubt instantly. And we'll discuss that either that moment or whenever we are doing one-on-one, like that. Got it, students? So make sure you go through those material also, because at least what I can do is I can share that with you and make sure that, okay, you know everything. You have at least read everything once. So that guarantees better things. Now, there are more relationships. What happens to dead space? What happens to skip distance during night, during day? That is there in your textbooks here and there. But I'll just share that for you all as a further reading thing. Make sure you all do. Okay. Otherwise, everything will be too complicated, and whatever I'm teaching right now might also go over your head, because you'll think, oh, there's so much to remember, so much to remember. So I want you all to remember this much at least first. So even if they ask you something, you can explain the basics. Got it? So no matter what they ask you, even if they ask you an advanced question of a topic, if you know the basics, you can explain the basics and fundamentals, and they will feel happy that, okay, wow, the student knows the basics. The student did not get time to study a little more ahead. Eventually, the student will finish. So we believe in the student. So you'll get the benefit of doubt. That is very important in your part one, first attempt of the exams. Okay, any questions? Propagation so far? Skywave propagation, HF. HF is used for long distance only because of ionospheric propagation. Otherwise, surface wave would not have given me long distance. Is there any other ionospheric propagation, or only is HF ionospheric propagation? Okay. You can say, note SATCOM, that is satellite communication. Okay. Now, these satellite communications are interesting. Satellite communications will use UHF or SHF. Now, these UHF and SHF, they actually travel via what is known as direct waves. Okay. But these direct waves, something that we're going to learn now, these direct waves for a satellite communication are transmitting in the ionosphere. Why? Because the satellites are in orbit in the ionosphere only, or somewhere in space, somewhere in ionosphere only. So although the satellites are conversing directly between each other and ground stations, that is happening in ionosphere only. That's why SATCOM is also included in ionospheric propagation. But that ionospheric propagation is not a skywave propagation. It's a direct wave propagation. Remember this difference. It could be a trick question. So SATCOM, UHF, SHF, direct waves in the ionosphere. Thus, SATCOM becomes ionospheric direct wave. Direct wave will write in bracket LOS, line of sight propagation. Now, this is a trick question. If you can remember, great. Otherwise, it's fine. We'll take a short break and we'll take a 5-minute breather. and we'll come back and we'll talk about direct waves. Anything above VHF will give you direct waves only. So up to VHF only we have to study propagation, no other problem afterwards. So that is the last thing in propagation. I want to discuss couple of errors, but I think all errors in one list would be easy for you to read. And after propagation is done, we'll talk a little about modulation, just definitions. I won't teach modulation in depth, but I will share notes. You can always read. All right. So let's come back. Let's take a short breather. 1010 hours, everyone. 10 minutes or 9 minutes, as it seems. Quick, okay? Students, welcome back. Is everyone back? Let me know verbally.
Affirm Victor Tango, Victor Golf Papa.
Affirm Victor Tango
Sierra
Nagar.
Alpha Hotel.
Affirm Victor Tango. Romeo India Mike.
Affirm Victor Tango Mike.
Affirm Victor Tango Alpha.
Sierra Juliet Lima.
I like your group calls. Nice.
Affirm Victor Tango Papa Kilo Mike.
Okay, so time for some jokes. Who's ready? Did anyone find a joke? Anyone? If you don't want to speak, you can drop it in the chat box. I'll speak it out. Anything that could make us feel it's a weekend, it's a Saturday. Something to reduce Vishnu's stress. Vishnu is freaking out. Vishnu, I'm sorry to say that. I'm just having fun. He's very calm, composed. Sharad is freaking out. I don't know about others. Priyam, are you freaking out? Yeah, but Priyam is very, very gentle with me. Priyam is not disturbing me at all, but I know he's freaking out. But I'm like, okay, Priyam, don't worry. I have a plan for you. Sajal, are you freaking out? Jyotsna, are you freaking out? Pooja, Karan, Sahil? Anyone?
Negative. sir.
Cool.
Affirm, sir.
It's okay. However you feel, you let me know. Maybe we can work on those areas also. Okay. Priyam 8th. Hardik is 3rd. Sajal is 6th, right? Nukul 10th. So I'm thinking, people who have exams together, like Sharad and Nukul, I'm thinking it would be much better if we could have a collective session. Pooja and Sharvari, of course. Not all sessions, but maybe 1 or 2 sessions collective. So together you could feel, you could feel that together you'll be giving exams. Probably you'll be meeting at the center also. So you all can connect that day, right? So yeah, I mean, we could try that. And then probably, one of you, even when you're not doing a mock with me, after you've done a few mocks with me, after that, Sharad and Nukul could just do mocks with each other, y'all. One could become the ATC once and the other could become an ATC once and practice more mock calls and then have discussions with me. That really increases your level of preparedness, preparation, I would say, in the examination. So that way it helps students. You can all choose whatever you want, like Sahil and Harsim also, but I'm not sure if they can connect because Harsim has connectivity issues. Good. No jokes, anyone? Okay, I have some chat box. No. Vishnu is like, sir, no jokes. The group call was funny. Let's make do with that one. Humor. Okay. Something is better than nothing. Sana, anything you have? Sajal, Sana, anything that can make us smile, laugh? Rishi? See, I'm handpicking students who I think would know a few jokes. I don't know. I could be wrong. Sajal, Sana, Rishi? No, nothing?
Negative, sir.
Negative, sir.
I didn't know your call signs were sir. Because that's how you end your responses, right? See, if you don't give me good jokes, you're going to get lame jokes from me. Fine. Let's do the third propagation. Okay, everyone? Okay, someone's laughing. Rishi is laughing finally. Priyam's laughing. Nukul's laughing. Nice. Nice. So let's talk about Vhf propagation now. Generally, the whole concept of Vhf propagation will apply to all aircrafts. Correction. All frequencies above the Vhf frequency. But as the frequency increases, the range will keep decreasing. Remember that. So VHF in skywave propagation, after skywave propagation, VHF, whatever mode of propagation VHF uses, VHF gives us the maximum range directly. Okay. So VHF and above propagate via sorry, you can call them space waves. There are multiple names given to them, okay? So VHF and above propagate via space waves, also known as direct waves or line of sight waves. Line of sight can be set as a LOS, line of sight. Line of sight. Remember yesterday I said, for as long as you can see, as far as you can see, you can transmit. So VHF and above propagate via space waves, also known as direct waves or line of sight waves. And space waves can also travel as ground reflected waves along with traveling as direct waves. Now you might be thinking, sir, what's happening? Why not just look at it? So simple, it's the Earth's surface. Again, we make a transmitter. Okay. Now we make a receiver not on ground, but we make a receiver somewhere in air like this. An aircraft. An aircraft is a transmitter and receiver both, right? And for ground stations, aircrafts are the receivers. Now, what is a space wave? VHF and above go through space waves. Simple. Okay, the name given is space wave. Now they can travel via two methods, a direct wave or line of sight wave. Now I'll make like this, two aircrafts right now. Okay, let's say this is Victor Tango Papa Mike Alpha and this is Victor Tango Papa Mike Kilo. Okay, now instead of Papa Mike Alpha, we'll do Papa Romeo Mike. Papa Romeo Mike. Now, the transmitter can easily see line of sight, LOS. This is line of sight between them. So, the space wave travel is possible as a direct wave or a line of sight wave. Okay. For Victor Tango Papa Mike Kilo, the space wave is not within line of sight because it's blocked by the curvature of the Earth over here. So there is no line of sight. So see, it is not in the line of sight. It is not. Because this is the line of sight you need and the Earth curvature is coming in between. So this is not happening for me. No transmission happening. But here the transmission is happening. Okay. So this line of sight wave is called as direct wave. And the range is called as line of sight range also. VHF range or line of sight range. Okay. So what is the maximum range for this transmitter right now? We will see the maximum range would be anywhere where the curvature of the Earth. So this looks like the maximum range up to here. See. So this gives me a maximum range right now. Below this, no aircraft will be able to receive the signals. So the aircraft, if an aircraft is here, then the aircraft will get the signal. But the aircraft, if it is below, then it will not get a signal. So this aircraft is not getting a signal, but only this aircraft is getting a signal. So this is the limitation of line of sight or direct wave. But this limitation is not a problem because there are a lot of advantages. We don't have to go through the HF way of indirect propagation, go through ionosphere, critical angle, because HF components become very expensive because of all that. VHF direct waves are simple, but the only problem is range. So you will see most of your navigation, modern navigation instruments are using VHF and above frequency bands only. Because those frequencies are good, the equipment is cheaper, smaller. Plus clarity is good. Why do you think we are increasing to 2G, 3G, 4G, 5G now? Within 10 years, we have gone from 2G to 5G. Imagine what will happen in the next 10 years. People want to get faster speeds, faster speeds, faster speeds, faster data, faster data. One day, I think people will be able to reach out to each other through the computer screen only, like get inside and go out. Himachal directly. I want to visit Himachal. Any student wants to have a one-on-one class, please let me know. I'll come. That will give me a good reason. Otherwise, I don't feel like traveling because there's so much of work that I cannot travel. But I can travel for work. Priyam is raising hand. Sure, Priyam. Let's see. How's the monsoon situation? I avoid Himachal in monsoons.
Yes, sir. It starts raining anytime.
Yeah, the transport is very slow in monsoon. So
Yes.
yeah. Anyway, thanks. Let's see. I think someone's from Goa also, right? Anyone wants a one-on-one session in Goa? I think Pooja, you are somewhere there, right?
I'm from Sindhudurg, sir. Not from
Sindhudurg. I
Goa.
don't mind. I like Sindhudurg. It's all same for me. The whole Maharashtra coast till Goa is beautiful only. Like there's Ganpati Phule, there's Malvan, there's so much. I mean, I haven't explored everything. Yes, yes. Good, good. Anyone else, anywhere, living in an exotic location, not so exotic location? I'm just waiting when September comes, you know. I don't want to miss on my monsoon travels. There's one expedition we do at least once. So, yeah. But for that, I want you all to pass, okay? Otherwise, I'll feel very guilty in going anywhere, skipping classes for a few days, giving you holiday. Vishnu, please clear, okay? If you clear, then I might be able to go early. If not, then I might have to wait till 17th. And by then, monsoon, I don't know what will happen to monsoon. So, yeah. See, students, don't get distracted. I want you all to take it easy. Line of sight waves, direct waves, any confusion? Okay, understood how it works. Line of sight direct waves are a part of space waves. Okay, now there is another part of space wave called as ground reflected wave. So what happens is these waves, they are not as bad with the curvature of the earth. Sometimes these waves can also be transmitted like this. It will go hit the earth and then it will be reflected back to the aircraft. I'll make this in green. So it will go, it will hit a surface and then it will go to the aircraft. It can happen. It can happen as a planned effect or it can happen as not a planned effect. So sometimes you will get stray frequencies also. Stray as in something that you don't want is coming to you. That would happen because of ground reflected VHF or other signals, VHF or above. So this green one is called ground reflected radio wave. So they both are a part of space wave only. Don't get confused thinking this is surface wave. Surface wave doesn't behave like this. Surface wave here, if I want to show you the surface wave, LFMF, then it would be like this only, following the curvature of the earth, like this. That would be surface wave for you. But we are only talking about VHF and above, so no need to make the surface wave. We'll say VHF and above. So we make a simple flow chart and we say space waves. Space wave can travel as either direct waves or line of sight and ground reflected waves. Now, again, I'll write note. SATCOM, satellites communicate between each other via space waves. But as these are orbiting in ionosphere, the direct wave propagation happens in ionosphere, and thus such a direct wave or space wave propagation is also called as ionospheric propagation. Remember, satellites will communicate with ground stations via space waves only. In between also space waves, ground stations also space waves. Just because in between they are communicating in ionosphere, we can say that is also an ionospheric propagation. And obviously from the ionosphere, the signal is coming to you, the ground station. From you, the signal is going back in the ionosphere in the satellites. So it can be termed as ionospheric propagation. Don't confuse it with skywave propagation for SATCOM. It will not behave like that. It will not have a critical ray. The energy is too high to be refracted back from the ionosphere. VHF and above, the energy is too high. No critical angle will give us a skywave return or a critical ray return for a VHF and above. No signal. Everything will escape. Everything will escape. Only HF is one that slot which will give us that total internal refraction properly. LFMF cannot also do it. So HF is like that medium thing in between the two. Also, you'll come across certain instruments that neither will be in this band or this band, but towards the end of one band and in the beginning of one band, like ending MF and starting HF. Certain instruments will be like that. So don't be surprised. Just follow the notes and try to make sense out of it. Okay. Any questions? Understood what is space wave, direct wave, ground reflected wave? Easy. The flowchart is easy. Any confusion? Take a couple of minutes, go through propagation completely. Propagation is over, errors you will be reading. And I think nothing else much needs to be discussed right now in propagation. Remember VHF and above transmits like this. Range, I have not given in these notes. I want you to add it. LFMF, range 3 and 2. VHF range 1.25 into square root of transmitter plus square root of receiver in bracket, right? Those range formulas. Remember, don't forget the mathematical calculations of frequency, wavelength, and time. Practice as many as you can. They might not give you a complicated question. They might not give you a very easy question also. They might give you a tricky question. They might just give you one number, any number. Maybe they must have given that number to other students giving part 2, and maybe they could not come up with an answer, and it could be the first person to come up with an answer. Or maybe they are giving you a unique question. You will never know that. Okay, you don't know if they're just making it up in their mind, or they've pre-decided a set of questions to ask you. Generally, they will have a preset of questions, but then they can always ask you more questions based upon your answers. Or less questions, of course. Any questions, students?
Sir, they may be asked about layers, different layers, D, E, F1, F2.
Yeah, they can. Why not? So to do, put layers of ionosphere. So basically during daytime, there are layers, higher level of ionosphere. During nighttime, the layers, like I said, there are different layers earlier. One of the two layers merges and becomes one layer, and the height of the ionosphere falls down at the night. So in short, you have been explained everything in detail. You can just do further reading as of now. If we have time in future, sure, if you want a lecture, I'll deliver. Or if I have time, I'll deliver. If I think it's required, everything else is done, then I'll deliver a lecture. Not a problem. But until then, make sure that these points are there in your further reading as a backup plan. At least you will know something, if nothing, like that. Still, when it comes to propagation-based questions, no matter what they ask, if they ask you, tell us about different layers of ionosphere. Sir, I'll tell you about ionospheric layers, but let me tell you about the importance of ionosphere and tell what you know. Okay. And then tell that there are layers, a few layers merge at the night, lack of sun, the layers come down, with sun layers go up, and tell about the frequency differences. Lower frequency night, almost half, higher frequency during day, almost double of the night frequency. At least say this much. even if you don't know the layer thing, because we have not studied that in class. Are you understanding? Even that is, if that's your concern, what will I do? Then have this as a backup plan. If you act like this, if you give answers like this, you will get the benefit of doubt. Trust me, you will clear. Simple. If you're like, sir, D, E, I don't know, something like D, E, sorry, sir, I cannot recollect. No, don't do that. Getting it, students. Whatever you know related to topic, say that. And then say, sir, that's all I can recollect right now about this in the end. That's it. Play it safe. So you might be thinking, what is sir actually teaching? Then I'm teaching you what to do in the worst possible scenario. I hope you understand. At least some of you all might not face all these problems. It could be easy for you all. So layers of ionosphere, it's not difficult, you know. And then factors affecting propagation. These are the errors basically. Factors affecting propagation. And what else? Range formulas are given to you. What else? I think this much is enough. Only a couple of things are pending in this topic. Okay. Actually, the reason I'm not doing it is because then it's time consuming, you know. It's time consuming, nothing else. Okay, let's quickly do the next part of your radio wave theory. Quickly. We'll do the next part. What is the next part? It is modulation and demodulation. So remember, demodulation would be opposite of modulation. Whatever you're doing in whatever type of modulation, demodulation would be opposite in steps. Okay, so first we learn about modulation. That is more than enough. Okay. Sorry. What is modulation? Now you all already know this. If you remember, try to recollect. I'd given you a few pointers on this, verbal pointers on this yesterday. But what is modulation? Simple definition you will give, verbatim if you need. Modulation is the process of superimposing a audio signal or a radio frequency on a high energy, high frequency, in inverted commas, carrier signal or carrier frequency. This is what they are looking for as an answer to modulation. Okay, this is a universal language that we use in aviation. Everywhere else, of course, even electrical books you'll come across. Modulation is the process of superimposing an audio signal or a radio frequency. So this audio signal or a radio frequency is the same thing, just different words. Okay. What is the audio signal or radio frequency? It is my voice that I have to transmit over a long distance, or it is my intelligence or a report or a signal or a data, anything that I want to transmit over a long distance. Okay. What is a carrier signal? It's like the aircraft. I cannot fly, but I want to go to America, let's say within a day's time, but I cannot fly. So I built a plane. I get onto a plane. The plane has high energy, right? More than me, of course. Similarly, the audio signal or radio frequency is that intelligence which is superimposed. It's stuck or attached to certain electronic radio processes. And then the carrier signal has that energy to be transmitted with respect to, if it's VHF, then limited to VHF ranges. If it's HF, limited to HF ranges, respectively. Got it? So the range will always be determined by the formulas. But then the carrier signal, how do we generate this carrier signal? Okay. So one thing that I'll tell you, something to do with electrical. Carrier signals or frequencies do not have any data on them. So intelligence and all simply will use one word, data, for our purpose. In different textbooks, different words would be there. Okay. Carrier signals of frequency do not have any data on them. They just act as carriers of our messages or data, so that our messages or data can be transmitted to wherever we want, no matter the distance, without any loss of the message or data. That is very important. If someone tells you that, why don't you try to transmit your original data directly? Why do you need to modulate? You say, even if I try to do that, my original signal doesn't have the frequency or energy to reach out to the range where I want my signal to go. It won't go. It doesn't have the energy. It doesn't have the frequency to go. But I need it to go, so that pilots who require my assistance can utilize my assistance following my voice, or people who need the data can get the data anywhere they are. They don't have to physically come to me and collect a piece of paper to get the data, like in old days. Got it, students? You understood what is the meaning, what is a carrier frequency, carrier signal. Everything that you learn ahead in simple words would just be electronic ways or technical ways to put what, how all this is happening. Okay, try to understand as much as you can. Now, if you see the definition of very high frequency range, then the range is directly proportional to the square root of the distance or height of the antenna. So in order to increase the range, you have to increase the height of the antenna. Now, Vishnu is adding this point, which is correct. This is something that I was coming on to. The second most important reason actually is that you can still transmit, but you have to have huge antennas to ensure that line of sight range. Do you understand? Like in this example, if I want to cover Victor Tango Papa Mike Kilo, I can use the same antenna to send the data to Victor Tango Papa Mike Kilo. But what will happen? I'll have to increase the length of my antenna in such a way, and I'll have to create a humongous, a big size antenna so that I get this line of sight range over here. Got it? So that is practically not possible. So that is second reason that we modulate, so that the radio signal can do the hard work. But still that modulation is not going to do anything about the fact of line of sight ranges. Still that modulation, if done over VHF or more, will follow the line of sight rule only, while propagation. So you'll end up realizing that even after modulation, if you're using VHF and above, then you'll have to have connected antennas so that you get a larger range over the same frequency networks or similar frequency networks, but difference in frequencies. So you will see the first area would be given to, let's say, Mumbai control. Mumbai control would be on some VHF frequency. Then the next would be Ahmedabad control. If you are traveling from Mumbai to Delhi, that I'm saying, then the Ahmedabad control will have a different VHF frequency, but in the same range, same band. Just a unique channel because they both are close to each other. So the same frequency with the Pune-Mumbai effect will happen. Radio 91.1 that I was talking about yesterday. So channels will merge. That's why I give them different frequencies so that even when both the fields of radio intensity are merging with each other, still the signals can be differentiated. So one person will not get both the signals. And then the third transmitter will be Delhi control. So VHF, although I don't get range, but I can increase the range by connecting one antenna to the next antenna to the next antenna, like that. So I can do long range, but I'll have to change VHF to VHF to VHF, change frequencies again and again, change controllers again and again, control areas again and again. For HF, that is not the case. HF, one antenna could give you up to half of the earth, right? So that is not the case. Got it, students? So yeah, two reasons why you need modulation. First, to ensure we don't have to use high height of the runway, high height of the antenna. And the second thing is because the intelligent signal in itself doesn't have the strength to be transmitted over a long distance. So we need carrier frequency for two reasons. Okay. Without modulation, the antenna heights would tremendously increase for a particular range. Thus, modulation also helps keep antennas at a reasonable height. Simple. In simple words, this is enough. A carrier signal can be generated by what is known as an oscillator. Now, oscillator is a small equipment. It could be natural in origin. Okay, there are certain elements in nature, certain rocks or solids that act as natural oscillators, or you can make an oscillator. You don't need to get into depth. You just need to know there will be an oscillator somewhere in your diagrams that will generate carrier signal. Okay. An audio signal is generated by the speaker, that is you, as in human, okay, not the speaker, and the sound waves are then converted into electrical audio signal to be superimposed on the carrier frequency. So you should also know that your voice is not directly going on the audio frequency. First, it's converted into the relevant electrical signal. When I say electrical signal, what happens is, depending upon your frequency, okay, I'll just show this to you. Let's say this is a conductor. Okay. Conductor. So if I have an electrical signal called AC current, alternating current, Now, what is this alternating current? Alternating current is this only. Your sine waves, generally your radio waves or EM waves, are the same alternating current but a higher frequency. Listen this carefully. This is something that I'm giving you for knowledge, not specifically for RT exams. This thing you will not find anywhere else so nicely explained. But this is the fact that everybody assumes that people will understand on their own. But I've realized this another is a big gap in the learning of fundamentals. Okay. So AC current generally is that current which gives you electric shock. Okay. In your houses, the 3-pin pointers, the plug points, everything directly gives you AC current. Your mobile phone adapters and other adapters that you see come with your electronic gadgets, big plugs. Those bigger plugs are actually converting the AC current into DC current. Okay. And those machines that do not have those big plugs, adapters, just have a simple pin, that they are simply using AC current directly. So those machines are risky for you to use. Be aware, you can always get an electric shock if there is a leakage of the current. And the DC ones, even if you touch live wire or anything, you don't get a current. DC ones. That's why mobile charger pins and all, you don't get shocks. That's why people use DC, so that you can avoid getting shocks, basically. So DC, AC, they have both different applications. All right. Now, certain engineering students going for RT exams, especially avionics students, are asked these questions in part 2 Viva. But luckily, pilot students with no experience or up to CPL experience will not be asked, but this is taught to you in technical anyway, so they can eventually ask this. But chances are they will not ask. Still, I'm explaining this. Alternating current will be nothing but an electric current. What is electric current? Flow of electrons is electric current. Every atom or molecule has electrons. What is electric current? Whenever these electrons are freely moving or flowing in any conductor, that is the meaning of electric current. Okay. When these electrons are at a lower frequency, these currents are known as electrical currents. So if I say the frequency somewhere, I think I don't remember the chart probably, but somewhere something 10⁻³ or 10⁻⁴ up to is with electric current, and beyond that the AC current changes into radio frequencies. So basically what happens at lower frequencies, this AC current works as an electrical energy. Okay, and there is an electric current. What do? You keep one end of conductor open. Okay, so this is one end of the conductor open in space or atmosphere. Then you pass on the AC current at a very high frequency through that conductor. Not when I say very high frequency, it doesn't mean VHF. It will include VLF also here. VLF is higher frequency than the electrical currents. So when you increase that frequency, so what happens? Let's say plus minus I'm using to supply current. Plus minus denotes a battery or a power source over here. Okay. So if the current is going inside like this, and if I open one end of the conductor, and if I increase the frequency of my AC and I keep increasing it, then that electrical current, after reaching certain frequency, gets converted into electrical energy. That energy is your electromagnetic radio wave. So your AC currents and your radio wave, the generation method is simple. Your carrier wave, your AC currents generation method would be simple. That's why we follow the same sine wave structure for radio waves. It's just that lower frequencies would act as alternating currents. And alternating currents, I'm not sure if you all know or not, but every alternating current gives rise to a magnetic field. Do you know that, students? Induced magnetism, transformers, they all work on that. Eventually, when you do technical, you have to learn all this. I'm just introducing it. Don't get bothered. Try to learn and grasp as much as you can. This is a little extra for you. Okay. So even when you're dealing with electric current, you have a relevant magnetic field which is mutually perpendicular to the electric field in an AC current only. Okay, electric current. But when you increase that frequency and keep one end of the conductor open, there comes a point where that electric current will not come out of the open end, will not come out of the open end, will not come out of the open end. There will be one point where you increase the frequency enough of the AC that the current starts leaving the open end of the conductor and still transmits in air. That is how radio waves are generated. So those frequencies are very low frequencies, we could say. So those are electrical currents at such a high frequency that they can use the atmosphere as a medium of conductor. But then those signals are such that they are not going to give you a shock. So that is a good thing for us. Otherwise, all radio waves would have killed everyone in path. We all would have been right now totally dissolved. Right? But then super duper high frequencies, like beyond VHF, those frequencies are harmful for us. They are harmful. It's not like they're not harmful. As you increase, further the harm gets increasing. So they will harm, but there is a small batch of frequencies from VLF to VHF that doesn't harm us much. And then use, always remember use. You ultra, super, extreme after VHF to remember the hierarchy. Now, this radio energy, after reaching a certain frequency, will be radiated in space depending upon the polarization. Okay. Now, any open conductor on the other end in its path tuned to the same frequency will be able to receive it. So that's how transmitter and receivers work. This is the basis of wireless transmission. This is the basis of how radio frequencies got out. Okay, this is going back to origins. Something. So oscillators will be something that will make up a high frequency carrier wave for you. While my audio signal is converted into electrical here. So my audio signal, like I said, is going as an electrical signal. Your carrier from oscillator will also go into the modulator. Together, they will be combined on top of each other. And then the carrier will be sent to a distance like an airplane. Then it will go. Then what happens when we reach our destination? Does the plane drop us directly on the roof of our houses? No, right? It lands us at one place, that is an airport. Everybody has to go to their respective destinations from the airport on their own. So the carrier frequency's job is just to reach the destination. But can an airplane land at any airport? No. An airplane will only land at those airports ready to receive that airplane, right? Correct? You need permission. So similarly, your transmitted radio signals will also be sent, will only be received by those people who are ready to receive, basically tuning of the same frequencies and matching the antenna with polarization of the signal. So the job of the carrier frequency is done the moment it goes into the receiver. Afterwards, it's our job to make sure we also extract the signal out. So extracting the signal out is demodulation. So first the received signal will be amplified. First, the received signal will be amplified to arrange to balance out anything that could have been lost. And after that, whatever intelligence we need, we'll just take that and everything will be rejected. That there'd be certain more equipments doing all that. In the end, your voice electrical signal would be sent to a speaker where the speaker will convert the electrical energy into sound waves. That's it. All your music is produced like that only. Everything that you use every day is working on the principles that you're learning in today's class and what you have learned in yesterday's class. It's an ongoing process. That's why sometimes in part 2 Viva, you'll come across questions like, how does a light bulb work? How does a fan work? They'll ask any questions to anyone. There was a time when people were being asked questions like, do you know how the tube light works? 4 to 5 years ago. That question went on for a year or so. So people had to learn all that also. But that question was asked mainly to engineering students, not pilot students. So you have to understand that difference also, where you're coming from. Engineers are required to know how tube lights work because it's a part of their job. Airplanes have tube lights. You just cannot see them. They're hidden. It's like that. So that's how receiver and transmitters work. I hope you have understood it, students, in simple words. Okay. Any questions or doubts? Students, remember yesterday I also asked you all to be a little interactive in class. No questions?
Negative. Victor Tango, Victor Golf Papa.
Remember the definition of modulation nicely. It's simple. Understand it nicely. It's simple. Okay. Only Vishnu has and doesn't have any doubts. How about others? Now, Vishnu is precisely instructed that Vishnu, whatever you're learning, consider that to be a final level of preparation because we don't have the liberty of time. So he's trying to affirm himself. He's trying to be ready. What about others? Don't you have your exam, students? Just because I've not done your one-on-one directly, will you not acknowledge? Are you upset? Are you feeling ignored? No, right? Then why you're not talking in class? Students, if I keep talking, you'll not understand much. We all know that. We all know how good training sessions are and how bad training sessions are. It's always two-way, right? No questions? Very good.
No, sir.
Negative Victor Tango Mike Echo Delta.
Very good. No problem.
Negative Victor Tango November Kilo Charlie.
Okay. Ideally, I wanted to leave you all early, but then our definition of types of modulation is not over. So I want to cover that. We try to do it fast, but of course, it can take always any time that as much as it takes. So we'll stick to the schedule. We'll take a break and we'll come back at 11:30, do modulation. And I also want to show you a few block diagrams. If possible, we'll do that and we'll wrap up the session here. So what about other topics? Individually, Vishnu, I'll tell you what to do next and we'll plan. Sunday, we don't have a class for everyone or anyone. Monday we'll have. So Monday we'll continue with the way we are learning. Monday, Tuesday, Wednesday, we are dedicating. So we'll cover up more points for part 2. Simultaneously, we'll be doing part 1 individually also as per the sequence, right? Students who have their exams on 30th, 3rd, 6th, please get in touch with me proactively and don't wait for me to reach out to you. Okay. If you think you need attention early, just be behind my back and I'll make sure that we end up doing it. Simple as that. Okay, so 11:30 we'll come back. We'll take a break. We'll write down the types of modulation, make sketches of those modulation and write definitions. And then we'll do block diagrams if possible. All right, students. I'll see you all 11:30, everyone. Okay, come back. And yes, that's it. I'll see you all. Students, welcome back.
Mumbai ground, Victor Tango, Victor Golf Papa. How do you read?
Vishnu, energy, energy, energy. I'm not going to respond unless you give me some sort of difference. Try again. Vishnu, are you trying again?
Yes, sir. Actually, let me try again. Stand by.
Mm-hmm. Welcome back, everyone. Any doubts so far? Now we'll make it quick. In short, we'll learn everything as much as we can, definitely. I think a couple of students are yet to join. Mhm. Vishnu, call is fine. Everything is fine. It's good that we have reached this level. Now just imagine as if you were Ranveer Singh or someone while taking the call. You'll get a lot of energy. I don't know how, but make it work. Try to make it work. See, it's not going to impact your performance. Don't worry about it. Just try to do it. Vishnu taking too long.
Affirm, sir. Victor Tango, Victor Golf Papa.
Yeah, this was a good reply. Although fast, but with good energy. Same energy, but slow rate of speech.
Right.
That's it.
I think it's happening somewhere between that writing and reading. So yeah.
Figure it out. Come on. See how you'll do it. Try to do it. Just keep trying. Simple. Don't struggle. Got it? Don't struggle. Don't feel bad. Nothing. It's not something that will make you fail if you don't have energy. Even if you don't have energy, if your calls are good, excellent, you will pass. Just know why we are doing this. In case something goes wrong, these things will help you get the benefit of doubt. So you don't worry. You have nothing to worry otherwise. Couple of students are still have not yet joined. I'm not sure who. I think Sahil. Yes. And one more student. I'm not sure. Sharad, I guess. Yes, Sahil and Sharad, right. Got it. Sahil has just joined. I'm not sure about Sharad. Sahil, welcome everyone. I hope everyone can hear me. Rishi, Anwar, Nukul, Pooja, Karan, Sahil, Vishu, Jyotsna, Sajil, Sahana, Priyam, and Ayush. Sharad is missing. Okay, fine. He's also not keeping well. Let's just write down about modulation first, and then I'll give you extra few important pointers related to all these points. Before modulation, I want to clarify a couple of things. Yesterday or day before yesterday, whenever we were doing a structure of a sine wave, we saw that this is the wavelength, one cycle, and we saw frequencies cycle per second. Whatever the cycle per second is, that is frequency. Now, I was talking about amplitude. I said amplitude could be this or that. Amplitude will always be measured from this horizontal line till the max. This is the amplitude of the signal. Amplitude generally could tell you the magnitude. Amplitude is like the magnitude. So we can say positive amplitude, negative amplitude, like that. So this is the amplitude. The entire length is not the amplitude. Only this much is the amplitude. And of course, this is also the amplitude. We can say this is negative amplitude. This is positive amplitude because it's above, that is below. So that is the amplitude. Okay, students? Remember also we had learned about period. Period is the time required to generate one cycle. Right now, we'll talk about modulation. We already know the basic definition of modulation. Now we'll write about types of modulation. Two important modulations used in aviation voice communication or otherwise, they are frequency modulation and amplitude modulation. Now, one more correction I want you all to make. In this definition where you have written down, make this correction, everyone. Modulation is the process of superimposing an audio signal or a modulating signal. Don't call it radio frequency, because most of the books, radio frequency is a term given to carrier signal. Okay, so we'll correct it. We'll say superimposing an audio signal. This audio signal is also called a modulating signal. Just in case we are not using audio, something else, then the common word is given as modulating signal. So our voice is modulating the carrier frequency. The carrier frequency will be modulated as per our voice and all, because we are the intelligence, or our signal is the intelligence. So modulation is the process of superimposing an audio signal or a modulating signal on a high energy, high frequency carrier signal or a carrier frequency, also called as radio frequency. Make this correction, everyone. Okay. Types of modulation. Number 1, keyed modulation. Keyed modulation. Now, this modulation doesn't really have a superimposition of a carrier and a radio. This is one of the oldest form of modulation that we use. Okay, write down the definition. Keyed modulation is achieved by turning off the transmitter for a short duration to get a dot, or for a longer duration to get a dash. Dot dash. This dot dash is basically an audio tone. It's basically a transmitter with one tone, like a beep, continuous beep. You turn it off, you bring dots and dashes. Another way to understand is that you turn it on for a short time to get a dot, turn it on for a long time to get a dash. Whatever way, the output is the same. Now, if I have a, what do we say? Let's say if I have a constant ring, like a tone, I don't have anything to demonstrate a tone right now. Let's say there's some tone going on. If that tone is breaking again and again, like in small bursts, then it's called dot. In longer bursts, it's called dash. The classic example of this is Morse code. So Morse code has a combination of dots and dashes converted into the whole alphabet. So a combination of dot dash could be A, dot dash dot could be B, dot dot could be C, like that. There's a whole alphabet in Morse code. So in older days, and even now, emergency, SOS, XXX, all those could be transmitted via Morse code if nothing is working. Okay. Another explanation, keyed modulation is achieved by interrupting carrier wave to give short, and the interruption means disconnection only here, to give short and long bursts of energy. Short is dot in bracket, long is dash of energy. Okay. Use of Morse code is keyed modulation. And KM, keyed modulation, is used in telegraphy. This is telegraphy. If somebody tells what is telegraphy, this is telegraphy. Morse code is telegraphy. Note, some NDBs, non-directional beacons, they are associated with ADF. These are the ground stations of ADF. Some NDBs use Morse code for identification. So even today, if somebody tells you, is there any application of Morse code? Yeah, certain NDBs have those identifiers or identification codes in Morse code, dots and dashes. Second type of modulation is amplitude modulation, AM. Now, amplitude modulation and frequency modulation is important. So remember, you focus on the definition clearly. In this, so basically from here on, the superimposition starts. In keyed, although we have said interruption of carrier node, only carrier is used in keyed modulation. Intelligence is not there. Just one high frequency radio wave and dots and dashes. No intelligence is there in those dots and dashes. Don't think in the dots you will hear my voice or in the dashes you'll hear my voice. No, it's just dot and dash. If you all want, you can always look up a couple of videos on Morse code and see how it sounds. Simple. Certain people can use the flashes of light also in Morse code. Small flash, long flash, small flash, long flash. Some people can, any sort of code can be used. In a movie, I'm not sure if you'll have seen this, but some person is kidnapped, but live on TV, and the mouth is like this. So the person cannot say where the person is, but the person is live. So some kind of criminal is doing all that. Some police is catching. You all know how it goes, right? But how did that mystery end? That person who was kidnapped was blinking their eyes in short dots and dashes. And the person looking at the video was able to figure out that this person is blinking in a rhythm, and that rhythm is like a Morse code, like this. So you can do it anywhere also. If you can build up that rhythm here, then dot, dash, dot, and then something you can do. I don't know how, but you can do something. So that Morse code can be useful anywhere, basically. Anyway, in amplitude modulation, in this type of modulation, amplitude of audio frequency, AF. Amplitude of audio frequency, this is your intelligent signal. Amplitude of audio frequency modifies the amplitude of radio frequency, that is carrier wave. This is the key point. What modifies what? How is the modulation happening? So whatever our audio frequency is, whatever sine wave we will get from our audio frequency, whatever kind of, it will not be an accurate sine wave. The amplitude of my sine wave or my waveform will modify the amplitude of the carrier wave. That's how modulation works. Simple. Something will modify something. What will modify what? Modulating signal, that is your audio frequency, will always modify the carrier frequency. But then which aspects will it modify? That is important. That's all that you need to remember for your RT exams. More than enough. You don't have to go much in depth. So in audio modulation, amplitude modulation, the audio frequency, the amplitude of the audio frequency. So why is it called amplitude modulation? Because the amplitude of the audio frequency is modulating or modifying the amplitude of the radio frequency. Amplitude modulation is simple to understand. Got it? The amplitude of radio frequency modulates or modifies the amplitude of carrier wave or the radio frequency. Again and again. This is exactly how you have to say this in the examination. Amplitude of the modulating frequency, that is AF, modifies the amplitude of the radio frequency. Simple. I'm explaining it again and again This is all that you have to do. Otherwise, you'll be confused what to say. In amplitude modulation, amplitude or audio frequency modifies amplitude of radio frequency, that is carrier wave. Got it, students? Easy? So, let's say this is my audio signal. Okay, let's say this is my audio frequency. So what is my amplitude? This is my amplitude. Okay, this is my amplitude. This is my amplitude. This is my amplitude. Got it? Now, I am feeding this along with my high frequency carrier wave. So see, my carrier wave will always look like this in your diagrams everywhere. So see, the frequency is too much, lot of cycles per second, plus you see the amplitude is also too high. It's high energy, high frequency, basically, constant. So this is your radio frequency or your carrier signal. When you combine the two, what do you get? You get this AF. So we'll make this AF in green like this. So what happens when you combine? What happens? The result combination will give you a resulting waveform like this. So your audio frequency amplitude will stay the same, but it will come in two places like this, above and below. So the modulation, the amplitude. So this is how it becomes. And what happens to your carrier frequency? The carrier frequency, the modulation, the amplitude of the carrier frequency matches the amplitude of this radio wave. See, it's going up and goes down. Again, it decrease, then increase. So the frequency of the carrier wave will still remain the same. We need that frequency, of course. But then you see the amplitude here was constant, both sides for the radio frequency. But now the amplitude is varying as per the amplitude of the AF. Okay. So you can write the amplitude is modifying the amplitude of the radio wave. The amplitude of AF modifies the amplitude of RF. Amplitude of AF modifies amplitude of RF. This is the diagram. If possible, try to show the diagram. Okay. If they ask this question to you. Yeah, Vishnu is saying he's seen in a movie that an aircraft was hijacked and the pilot communicated in Morse code by touching wires and turning on and off the lights on the tail of the aircraft. Yes. See? Anything available to you, you can use that to try and convince that in Morse code. So maybe that pilot would be doing either SOS or a code for hijack, that is 7600 squawk code. Maybe numbers are also there in Morse code. So maybe they can use those numbers also to indicate that. Now what is happening, students? If you carefully look, this is the positive amplitude, upper part. Okay. So this is the positive amplitude. What is this positive amplitude doing to the amplitude of my radio frequency? It is increasing both sides. Ideally, my radio frequency amplitude was within this range. See this total, this much. But then when I'm superimposing an audio signal on that, the amplitude is changing, frequency is constant, plus the positive amplitude of AF increases the amplitude of RF. So write down positive amplitude of AF increases amplitude of RF. And what happens to the negative amplitude? I'll mark it in blue. What is the negative amplitude doing? This part, what is the negative amplitude doing? The negative amplitude is somewhat reducing the amplitude of the RF from its actual amplitude. That's why the diagram looks like this, mirror image. So in the next point, you'll write negative amplitude of AF decreases amplitude of RF. Frequency of RF remains same. These are takeaways from your AM. Simple. There is one word that they can ask you about. That word is heterodyne or heterodyning. Okay? Heterodyne or heterodyning. What is this process? It's a simple name. Just be aware of this name. What is it? Later on, you can study in depth. Afterwards, like in future. What is heterodyne? Heterodyning is the process. Write down. The process of combining a radio frequency with a current at audio frequency is called as heterodyning. So modulation, in modulation, when you're superimposing an AF and an RF, that particular part in modulation is called as super heterodyning or heterodyning, not super, heterodyning. Simple. So the whole process is called modulation so that we can transmit and all. But simply combining an RF with a current at AF, basically audio frequency converted into electrical current, that process is known as heterodyning. We need to heterodyne before we can modulate. It's like that. Or heterodyning modulation go hand in hand. All right. Next point you will write, AM goes through heterodyning as RF combines with AF. We get 3 frequencies. So after you do the super heterodyning or heterodyning, there is a word super heterodyning also, but just stick to heterodyning right now. Whenever you're doing heterodyning, you are getting 3 frequencies. This is important. They can ask this to one of you all at least, if not everyone. Okay. What are these frequencies? First, we get unchanged RF. Okay. That is something that we have already discussed. Second, we get RF plus AF. And third, we get RF minus AF. These are the 2 additional frequencies generated due to heterodyning in amplitude modulation. So this is something that they can ask about. What will they ask? They'll ask you about something called as single sideband, SSB. Do you know what is single sideband? You'll be like, I hardly know this. How do you expect me to know that? But no, that won't happen. You'll say, yeah, I know single sideband. They'll say, what it is? You'll say, whenever you do amplitude modulation, heterodyning takes place, which is a process of mixing RF with AF. Whenever that happens, 3 frequencies are generated. One would be the unchanged RF, which would be actually the main carrier frequency, plus 2 more frequencies are generated, RF plus AF, RF minus AF. So total we have 3 frequencies. It means we have 3 different signals now after AM. All these 3 different signals are transported together and intelligence or our information is carried on all those 3 signals. But do we need 3 different signals to give us information? One is enough for us at the receiver end. So we use only one out of these 3, that is single, one use, that is single sideband. But why is it called sideband? Now that is again interesting. So when you see, you are getting this modulated waveform, in the center you are getting your RF frequency. Okay. Above you are getting this line that you see over here. It could represent RF plus AF. It is called as upper sideband. Write down USB. Upper sideband. This complication in modulation is only with AM. Frequency is very simple to understand. And the other frequency, RF minus AF, is called LSB. Lower side band. So what happens? The receiver is designed in such a way that it will only take one sideband, upper or lower, and it will reject the other two. That way, the receiver construction will also be less complicated, cost will also be less complicated, weight will also be less complicated, or less, that is, weight is also a factor in aviation. And then we take one sideband, RF plus AF. Out of that, we reject the RF also and just take the AF and modulate and convert it back to voice and get the data out. Simple. Are you getting it, students? So that's why these key points are given to you. Study them one by one. Take your time after the session. Take a break, and after that, sit and read it again nicely. And if you have doubts, discuss with me. Okay, I'm not expecting you all to understand, like remember everything right now, but just understand. And then you can read. Okay. So generally, information is generally said to have been carried in both the sidebands and not the radio frequency inside, because the amplitude is with the sidebands only on both sides. So observation you will write of AM. Quickly, these points and will be done with AM. Amplitude modulation, observations. Write down number 1. Power is equally divided between the two sidebands. So the total power is divided between the two sidebands. Whatever power, everything will also have a power in watts. Okay. Second observation, information is contained in both sidebands and number 3, 1/3 of signal carries information. So what I said earlier that the information is divided in 3 parts is also true, but this definition that power is divided in 2 is also true. So do not get confused. Okay. SSB, single sideband operation. We use only one sideband and reject the other as well as the RF at receiver. Now you already know both sidebands also have information. So one sideband will also have information. So this is single sideband technique or single sideband, whatever they say. This is it. Simple words. Just write benefits of SSB. They can ask why you want SSB, just in case they ask. You will say, number 1, reduces static interference effects or effects of static interference. Static interference is atmosphere's own electrical interference in your signals. That is static interference. So atmosphere also has electrical charges. If in skywave propagation, okay? Only in skywave propagation. Why? Because most of the ions in the ionosphere will be electrically charged, so will cause more interference. Number 2 benefit, it increases the number of available channels. Because we are using only single sideband, that is a smaller frequency, we can use more frequencies, that is more channels in an available band. So increase the number of available increase the number of available channels in MF and HF band. Third, better S to N ratio. S to N ratio is signal to noise ratio. Signal to noise ratio is basically how clear or how good is your reception compared to the external atmospheric disturbance or interference, that is noise. That is basically, in bracket you will write less static interference. Static interference in simple, I'll tell you, interference because of atmospheric electrical current or charges. Fourth, because you're doing single sideband, you need less power required. And whenever there is less power required, thus equipment becomes lighter. This lighter we need. Lighter as in weight is reduced. Note, a microphone is first required to convert audio frequency into electrical signal. A mic, or mic is short form for microphone only, students. A mic or microphone is a device that converts sound waves into electrical current. Okay. Take a quick look at our amplitude modulation. See if you have any questions. Quick. Let's get done with frequency modulation. There are two more modulation, phase modulation and pulse modulation, but we'll not be doing that. Up to frequency is fine. Any doubts on amplitude modulation so far? Even if you have understood a little bit, that you will be able to give a few points, that will be more than enough. But trust me, in the most simplest words, I've explained a complicated system of amplitude modulation, which is, I could say, quite enough. This much is quite enough, along with further reading for CPL studies also for this topic. So RT definitely is going to be enough. But make sure, if you act like specific questions, I don't know. And if you don't know, still, you will end up knowing the basics because I'm teaching you all the basics. So make sure you say the basics at least in questions before saying I don't know the answer. Okay. No doubts. Take your time. I'll give you a couple of more minutes. Go through the notes, amplitude modulation, see if you have understood every point. If you have understood, if you have any confusions in understanding, don't say I'll do it later. Do it right now. Discuss it with me right now. If you're confused anywhere. Okay, good. Frequency modulation. Come on, everyone. Simple. Write down frequency modulation. What is frequency modulation? In frequency modulation, the amplitude. So here also the amplitude of audio signal modifies. In both places, it's the amplitude that is modifying the carrier signal. Remember, otherwise we think in amplitude, it's amplitude that modifies. In frequency, it's frequency that modifies. No, it's not that simple. The amplitude of audio frequency modifies the frequency of RF. That's why it's called frequency modulation, because the frequency of the carrier signal is modified by the amplitude of the audio frequency. So let's say this is your audio frequency plus, let's add your carrier wave radio frequency. What do I get? Now my modulating frequency is modifying the frequency of my RF. So my amplitude of RF is going to be the same. Earlier, my amplitude of RF was changing, right? Big and small, big and small. So here the amplitude is not going to change. The frequency is going to change. So the positive magnitude of your AF will increase the frequency and the negative amplitude will decrease the frequency. Simple. This is a very simple explanation to a complicated topic. Understand it this way and explain it this way, and you are good to go everywhere for these topics. Everywhere, not just RT exams, everywhere. Wherever you are required to give that answer. So what do you get? Let's make your audio in blue. So your signal. So if this is the range of the amplitude, just as a rough, so the amplitude range is still the same. I'm just showing it to you for reference, this line, to show you the amplitude range. But the frequency changes. So wherever there is positive, the frequency is more. Wherever there is negative, the frequency is less, like this. Then again, frequency more, then the frequency is less. Then again, frequency more, like this. So you see, in a little part, there are more cycles per second. Afterwards, in between, there are less cycles per second. Then more cycles per second, then less cycles per second. So Jyotsna, focus what I'm doing when in frequency modulation, when AF and RF are combined, heterodyning, of course, the amplitude of AF modifies the frequency of RF. How? Like this. So the positive amplitude increases the frequency. See here, the frequency is high, and the negative amplitude decreases the frequency. Negative, positive. Positive, this again negative, then again positive, like this. So this is the positive amplitude of AF increasing the frequency, and here negative amplitude of AF decreases the frequency of carrier wave, like this. So this is the modulated signal. In the end, the output that you get, this is going to be transmitted through sky waves or direct waves or whatever modulation you use wherever. So this is called high, this is called low, this is called high, this is called low, again high and low. Students, if you are understanding it right now, then trust me, you are very lucky, and I'm very happy that you're understanding it so easily. Otherwise, it's very complicated to understand and remember both. I've seen that every student faces that. But if you take this time and understand it, then no matter which textbook you read it from, you'll just see terms are different, but the ultimate logical understanding is this only. Are you understanding, students? So no matter what textbook you read, BL Thareja, something that electrical engineers or engineering students use, even that will make sense to you. Or something like a ground studies for pilot book that is only for aviations with a simple language, that will also make sense to you. Otherwise, it will go over your head when you don't. And it has taken me a long time to convert all these in these simple language and simple terms. You might think, sir, amplitude modulation is too much for me. It is simplified for you. This is the least that we could simplify in with covering all important points. One line each. It's not rocket science. So you have to try to repeat 100% of this at least. Anything asked about modulation, you know modulation, whatever you know, you speak. Simple, but in proper sequence. That's it. So write down. In FM, the frequency of RF changes as per the positive or negative amplitude of AF. The positive amplitude increases the frequency to give a high. The negative amplitude decreases the frequency to give a low. In other words, the frequency deviation. Frequency deviation is basically the change of the frequency from the earlier frequency. So the frequency deviation of RF in FM, so they can say the frequency deviation of RF or frequency deviation in FM, any word could be used, or simply they could say frequency deviation. The frequency deviation of RF in FM is primarily dependent on what? Of course, the amplitude of audio signal, nothing else. So is deviation in FM is primarily dependent on the amplitude of AF, audio frequency. That is, if amplitude increases, frequency deviation also increases. In other words, these are just different words meaning the same thing. Important point note, somebody can ask you about rate of change of frequency. Now, although my frequency is changing, there is one more element of calculation or measurement, that is at what rate is my audio frequency amplitude changing the frequency of my radio frequency. See, I have clarity, so I'm able to nicely say these words. You take some time, revise, and also you'll also get clarity. Otherwise, you'll always be confused. If you're rushing into it, then you will not be able to give good answers. Okay. So they will ask you about what about the rate of change of frequency? Will you say even that is dependent upon amplitude? No. Amplitude will either increase or decrease. But at what frequency is it increasing and decreasing? What is the rate of the change of the frequency? Frequency of the change of the frequency, basically. That's why it gets complicated. So the rate of change of frequency, in simple words, I'm giving it to you directly. If somebody says frequency deviation, amplitude. Rate of change of frequency and frequency deviation, they are two different things here. These are the only important elements in frequency modulation which I'm covering, okay? So rate of change of frequency in a modulated signal, that is the output, okay, is defined by the frequency of audio frequency or audio signal. So in frequency modulation, the frequency of audio frequency also takes place or holds importance in determining the rate of change of frequency. While the amplitude changes the frequency directly, at what rate is the frequency changing? That is controlled by the frequency of the audio signal. Okay, students? FM is generally unsuitable for use below VHF band. So this is a very simple but important point. They can ask you, can you use frequency modulation for HF? No, because it's not suitable below VHF. So VHF and above, I will use FM. So any instrument using frequency modulation, sorry, any instrument using VHF band if they ask you what kind of modulation it is using, do say, sir, I have not studied all that. Don't say that. Simply say, sir, if the system is using VHF or above, then only FM will be suitable, because FM is unsuitable below VHF band. So below VHF band, if the system is using below VHF, like HF, LF, MF, ADF and all, then they will use amplitude modulation. Other systems that have VHF and above, they can either use amplitude or frequency, whichever is more applicable. So even though if you don't know a specific answer, you are able to give an answer to a question. Do you understand what I'm doing right now? Because you have studied something at least. So this should ideally be, because even though if I teach you 500 topics, what if they ask you something that is outside that? What will you do then? Do you think you don't know anything about those topics? If you have learned 500 topics, obviously you know something or the other related to those topics. So bank upon that, speak that. Try your best. Don't be blank. Simple. There are two more modulations, phase modulation and pulse modulation, but we'll keep it. It's okay. It's okay. I mean, these two types are more than enough. You have already done one more extra, that is keyed modulation, as a general knowledge. VHF ATCs, Vishnu, will only use frequency modulation because frequency modulation is unsuitable below VHF. So VHF and above, either FM or AM. Now that totally depends actually. But yeah, this question I will answer. Put it in your parking lot, okay? They can ask like what kind of modulation is used by VHF ATCs. So yeah, of course. So take a couple of minutes, go through your definitions, all your notes, see if you have any questions. Keep asking more questions. Vishnu, I'll answer your question now. Students, if you have any questions, just directly ask, okay? I'm not looking at the screen at the moment. Vishnu is saying he's read that communications use amplitude modulation. He's not sure. Good, good. No questions, anyone? See, I'm not gonna ask you questions right now. Idly in a class, we could do that, you know, check if you have learned or not. But I'll be asking you questions when I'm doing one-on-one with y'all. So make sure you're prepared for part 2 also, whenever your time comes. No questions? Okay. Let's talk about aircraft comm systems. VHF. First write HF, then VHF. HF, VHF. Important pointers could be asked to you anytime. Point number 1, long range, VHF. short range. Number 2, HF, skywave, and VHF, space waves, or line of sight waves. Okay. Same. Type of modulation, single sideband, amplitude modulation. Simple. VHF, I'm confirming. Some people will say HF communication can go with double sideband also. Point number 4, frequency band that we use for voice communication is between 2 to 30 megahertz. 2 to 30, generally the range starts from 3 to 30, but we also use the higher MF band, that is 2 megahertz. So frequency band is 2 to 30 megahertz for HF. Write it down carefully. The propagation is affected by selective fading. Now you can put fading in your parking lot. When I give you the list of all the different factors affecting propagation, you can just give it a read. Fading is the loss of signal strength over distance. Okay. And there's one more thing called attenuation. Okay. Attenuation is also something like that only, but all these things you just read there once. How many HF systems do you have on a large transport category aircraft like A320, 737 and all? Boeing 747 also. Planes like that, at least 2. HF1 and HF2. At least 2 systems will be there. Okay. One as a primary, one as a backup. We could say, although both could be used by both the pilots generally, but 2 will be as a standby and 1 will be primarily used. So there are 2 systems, HF1 and HF2, 2 completely independent communication systems. HF1 and HF2. Remember what I'm writing, number of systems. 2, HF1 and HF2. Those are the names, generic names for everyone. In VHF communications, write the third point about modulation. Write down. SCSAM. So amplitude modulation. To answer your question, Vishnu, somewhere what you recollected, I really liked it. How you used your memory to give an answer to a question that you were not sure. You ended up being right on that answer, Vishnu. How amazing is that? So you thought you know the correct answer. You have read somewhere it's AM. You are absolutely correct about it. It's amplitude modulation only. So this is what I'm expecting out of you all students. No matter what, try to go back in your memory and see something or the other would come back to you related to the topic. Because you have studied, right? You're good students. You know so much of things. You have so much of knowledge, experience. It's an exam where all that can come into picture. What is SCS? SCS, I'll just tell you. Single channel simplex. Remember yesterday I was talking about multiplex, multiplexing, simplex. This is that simplex. The meaning of simplex in simple words I'll give you. Single channel simplex means one frequency and one antenna, means one frequency and one antenna for both receiver and transmitter. And remember, your HF and VHF systems are also known as transceivers. Transceivers. Transceivers can transmit and receive one at a time. Can transmit and receive but one at a time. They are transceivers. Okay? Walkie-talkies. Mobile phones are like transmitters, transceivers, but modified version with multiplexing. Generally, transceivers will have single channel simplex, SCX. That SCX might not be asked to you, but it's good to know. Specific type of modulation. Single sideband, you already know. You can say single sideband amplitude modulation for HF, or you could say amplitude modulation only. But no, double sideband can also be used. And in place of VHF, that is single channel simplex, chances are double channel simplex can also be taken. Where we have, write this point down, where we have different frequencies for transmit and receiving, for transmission and receiver, we use D, C, S, F, M in VHF. Something extra. DCS is double channel simplex. So here the simplex will mean only one person can transmit at a time. Simple. Single channel will mean same frequency, same antenna. Double channel will mean two different frequencies, one to transmit, one to receive. It means two antennas different, one to transmit, one to receive. Simple. Somebody can tell you, are you sure only amplitude modulation? You say wherever we want to use same frequency for transmit and receive, like VHF comms, then definitely I use amplitude modulation. But places where I'm not using the same frequency, probably for radars, your radars generally have two different frequencies of transmission and reception. So there you can use frequency modulation with a double channel simplex. Double channel will means two different channels. Simplex would end up meaning only one person can transmit at the same time. See, in basic words, I'm trying to give you advanced information about fundamentals. Okay, try to grasp as much as you can, as much as you can. And for the frequency range for VHF, communication is 118 megahertz to 135.975 megahertz. Some people can also say 118 megahertz to 136 megahertz, but the last is not there. So this is more accurate. This is the actual range given to voice communications from the entire VHF band of 30 to 300 megahertz. Here they will ask you about channel spacing. Channel spacing means how separately are the channels spaced. That problem is not with HF, because HF same frequency we can use for entire range of our flight path. VHF, we know we have to be connected from one antenna to another, to another, to another. Frequencies will change. So what should be the spacing between the frequencies so that the overlapping doesn't happen? So earlier the spacing was only 50 kilohertz. That 50 kilohertz was giving us only 360 channels between 118 megahertz to 136 megahertz. Then we reduced the spacing to 25 kilohertz. When we reduced the spacing to 25 kilohertz, we got around 720 channels. And further, a small part of this range, we have further, in this range only, within this range, a further range we have reduced, and we have reduced the spacing to 8.33 kilohertz to get more number of channels. So earlier spacing, channel spacing, earlier channel spacing was 50 kilohertz, which gave me total 360 channels. Later, advanced, I got 25 kilohertz spacing in channels that gave me 720 channels. Now, I use 25 kilohertz also. And a range within this big range, I have spacing of 8.33 kilohertz also. That range, I think, is between 118 to, I think, 126 or something. Don't quote me on that right now. But yeah, that information is there somewhere. So you can put that in your parking lot. Range for 8.33 kilohertz spacing. Okay, what is the actual range? That range is actually shared with another navigation instrument also. Remember how the waves travel VHF, line of sight or space waves. Line of sight word you have to use. So you will use add it space waves. That is line of sight. Add it in your answer. That is the keyword, line of sight. 8.33 kilohertz. Okay. Any doubts so far? Number of systems. How many number of VHF systems ideally we will have on board a transport category aircraft? 3. What are the names? VHF1, VHF2, VHF3. Ideally 1 and 2 will be used by PIC and Copilot, and 3 will be on standby. Okay. For VHF, right, antennas are mounted in such a way to receive and transmit vertically polarized waves. So if anybody asks what's the polarization of VHF comm systems, you will say vertically polarized. Priyam, we cannot say directly it's 200 and 280 channels with 8.3 kilohertz spacing because the entire range is not used with this spacing. The entire range, as in 118 to 136, the entire range is not used for this spacing. Only a part of this range is used for this spacing, 8.3. So only a limited number of channels will be increased. Beyond this range, we will only follow 25 kilohertz spacing. So I'm not sure how you have calculated, but probably if you have calculated between the difference of the megahertz, and that's how you got 2280, then it's not right. Know the difference, okay? That's what I was trying to say. So don't quote me on that yet. I'll give you all the range. I'll verify. I think it's from 118 to 112, I guess, or 118 to 1128. Correction, 118 to 128. I'll give you all that. Don't worry. If anybody can find it, then good. Share it with me. Anyway, any doubts so far? Remember about voice communication systems or communication systems. These are the two types of systems. Okay, VHF, and we have included enough points, 6 with HF and 7 with VHF. Out of those, even if you say 2, 2, 3, 3 points on both type of systems, that is more than enough. Are you following, students? I know it can get tedious, students. Feel fresh. Just 2 more things left and we are done. Easy things. Okay. 1 second, all right. Yeah. Okay. Any conductor or a radiating wire can be a antenna for transmission and reception. Any conductor you will write with an open end or a radiating wire can be an antenna for transmission and reception, in simple words. Okay. Required length of antenna. What is the actual requirement of the length of the antenna? If I want to transmit a frequency of, let's say, a frequency, let's say 100 kilohertz, then how do I know what antenna is suitable, or what will be the height of antenna suitable to give me a good range for 300 kilohertz? So the formula is very simple. Ideally, the formula used is wavelength divided by 2. Whatever the wavelength is, if you divide that by 2, then that becomes the length of the antenna or height of the antenna that you can use to safely, easily transmit that particular frequency. But imagine if you're using a radio wave who has a wavelength of 1 kilometer, then can you use an antenna that is half of 1 kilometer, that is half a kilometer antenna? Half a kilometer antenna would be so huge. What about those frequencies which have 10 kilometer wavelengths, 5 kilometer wavelengths? Can you build such vertical antennas? It's practically impossible. Okay, you have to build concrete type buildings to mount those antennas, basically, to keep them safe. That's the whole idea. So that's why you see high-rise buildings. On those terraces, antennas are mounted to increase the range, basically. That's an indirect idea to increase the height of your transmitter. Such an antenna, whatever antenna you will get by this expression, such an antenna is called dipole. Okay. To reduce length of antenna, we use lambda by 4 calculation. Lambda by 4 antenna is called unipole. So if you know how to find out wavelength, then you can also give them the required height of the antenna also. So once find out wavelength, then just divide it by 2 to give dipole, or divide by 4 to give unipole. Dipole and unipole are basic types of antennas. Is an antenna a dipole or a unipole? That could be said. Then the antennas are a variety of types. But these are basic fundamentals of antennas that we can cover. Simple. Okay. Like simple. Example, if I say, I give you example. Dipole for transmission of 100 megahertz. How much will I get? What will be the height of my antenna for 100 megahertz? What's the wavelength? So we'll say wavelength is equal to frequency, correction. Wavelength is equal to C by frequency, right? Is equal to 3 into 10 raised to 8 upon 100 mega. So what is 100 mega? Simple, 100, and you'll write mega means 6 zeros after 100. So 1 followed by 6 zeros again is nothing but 3 into 10 raised to 8 upon 1 into 10 raised to 8, like this, simplified. So 10 raised to 8, 10 raised to 8 goes, is equal to 3 meters is the wavelength. Therefore, my dipole antenna length would be lambda by 2 is equal to 3 divided by 2 is equal to 1.5 meters. So if I have a higher frequency and lower wavelength, then I can use dipole antennas also. But still 1.5 meter antenna is big enough for an aircraft. aircrafts would require smaller antennas, much more smaller than 1.5. 1 meter is what? This much. I cannot even get into the screen. Maybe this much in my hand. I think this goes to 1 meter. 1.5 meter, that enough is a too high of an antenna length to be mounted on an aircraft. And plus ground station antennas, of course, this can be mounted. So understand this, okay? All right. This is something extra we are covering. And one more equation you have is with this is this. Speed of light is equal to lambda f, okay? This also is there. Some people can play with your mind. So don't get confused. This is just as c is equal to, if lambda is here, if you take f, then f goes here. Or c is equal to f and lambda goes here. It's the same thing, not different. But this equation can also come. C is equal to lambda by f. So remember, students, I was telling you about how the electrical current is actually converted into radio frequencies. I said something to do with 10 raised to 4, right? This is how picture memory helps us. Even though we are not naturally born with picture memories, we can develop that. It really helps because like Vishnu was able to guess, many of you all are able to do it. I am able to do it at times. 10 raised to 4 was actually correct. I'm giving you something extra, a table, EM spectrum, I'll call it. Okay. Something extra for your own information. Make this table and forget. Wait, I'll make the table nicely. You make the table. You already have a rule book, right? So the frequency of an electrical signal, okay, in hertz, okay. And what do we call these signals? If the frequency is 10 raised to 4, okay, 1 followed by 4 zeros, that is 1 kilo, I guess, or 10 kilo, I guess, 10 kilo, right? Hertz will mean hertz. It means 10 kilohertz, right? Correct? That is the meaning. This is how you'll be reading it out. So this frequency up to this frequency 10 raised to 4, we call the electromagnetic waves as electrical waves or electric waves. Okay. After this, if the frequency is increased further to 10 raised to 11, that's when your current gets converted into radio waves. Okay, this is where it starts for us. Then 10 raised to 14. So radio waves have a limitation. After that, if you keep increasing the frequency, you get what is known as infrared rays. People who have done metrology, you all might remember visible light has ultraviolet and infrared, two different sides of the spectrum of visible light. Okay. So then in between infrared and ultraviolet is always the visible light. So infrared is the lower end and ultraviolet is the higher end. So after infrared 10 raised to 15, we have visible light. You don't have to remember all, just remember radio and electric comparison, okay? That can help you. And then 17 is ultraviolet. So this is the visible light spectrum completely. Infrared is before it, ultraviolet is after it. Then if you're wondering what are X-rays, then X-rays are the same only, but at a higher frequency, 10 raised to 19 are X-rays. 10 raised to 21 are gamma rays. Gamma radiation are the worst for human beings and animals alike. So you know the level of frequency. It's double of radio waves approximately. And then 1025 is cosmic radiation or cosmic rays. Okay. Now there is another bifurcation of frequencies known as letter designator of frequencies. Okay. So we'll write down the designator. And we'll write down the frequency range. Designators are Lima, Sierra, Charlie, X-ray, Kilo, and Quebec. What is the meaning? Just like we have different frequency bands with different ranges, VHF, HF, and all, these bands also have a frequency range. Okay, so the frequency range in these designators is only in gigahertz. So it is a segregation of frequencies in the gigahertz range only. Okay, frequency range, F range. Shorter F is the frequency in gigahertz only. So these are all in gigahertz. So L means 1, 2, 3 gigahertz. Or I have a habit of writing 1 gigahertz also as with the unit. 1 gigahertz to 3 gigahertz. Then 2.5 gigahertz to 4 gigahertz is band S. So see, L and S are overlapping. It's fine. Okay, don't get confused thinking, sir, which is which. 2.5 to 3 will also be in L and 2.5 to 3 will also be in S also. So L and S will have a common transition line between them. Charlie, 3.5 gigahertz to 7.5 gigahertz. X or X-ray in RT, 6 gigahertz to 12.5 gigahertz. Kilo, 12.5 gigahertz to 40 gigahertz. And Quebec is 33 gigahertz to 50 gigahertz. Couple of bands are used in couple of systems in aviation. Like C is used by airborne weather radar. You can write that. Okay. X is used by Doppler radar or Doppler navigation. Doppler is another effect. You can read it later on. X also is used by plus airborne weather radar. Okay. And K is also used by Doppler. Doppler has its own principle. It is something to do with relative motion, and whenever you're moving, you transmit signals. So by the time the signal is received back, your position is changed. But if you can take your time ATPL level to understand Doppler if you want, no problem. Okay, a little more hard work with frequencies, students. We'll write down the, although you already know the application of frequencies with respect to the frequency table, there is a table wherein the systems are named and the accurate frequency band is also given. So even though we have not started systems, you will at least be knowing which frequency bands are there in the system. Okay. So write down airborne radio frequency uses. Okay. So we'll write down, I'm not giving you all, I'm giving you only main and the frequency band. LORANC. LORANC is basically long range communication. Long range communication. Okay, long range communication is using 100 kilohertz. All right. Then we have ADF. ADF will use 200 to 1700 kilohertz. After ADF, you write HF comms. So long range comm is a different system, LORANC C, And HFCOM is a different system. Okay. So HFCOMs use which frequency? Now you have more accurate description, 2 to 25 megahertz. Then ILS markers. ILS markers use generally 75 megahertz. Then you'll write ILS localizer, LOC. ILS localizer uses 108 to 112 megahertz. Then we have very high frequency omnidirectional ranging, VOR. VOR uses 108 to 118 megahertz. So you see, ILS localizer and VOR have a common set of frequencies also. Then we have VHF COM. VHF COM will use 118 to 136 megahertz, like discussed earlier. Then we have ILS glide slope. ILS glide slope is using 320 to 340 megahertz. Then I have distance measuring equipment, DME. DME uses 960 to 1215 megahertz. Then I have secondary surveillance radar. It has two frequencies, interrogation and reception. So there are two frequencies, 1030, 1090, radar. And then radar or radio altimeter frequency also you write down. So whenever you're doing systems, anytime you can just compare this table for your frequencies. Radio altimeter uses a very, very high frequency like gigahertz, 4.2 to 4.4. Then of course, airborne weather radar. Airborne weather radar has 5.5 gigahertz to be precise. So there are two types of weather radar. One weather radar using Charlie, and like I said above, another airborne weather radar using X-ray will use 9.4 gigahertz. X-ray as in the band X. All right. You need to have this list actually for avionics engineers also. Plus, I think these are common things, you know, they are common things. So this is like your first step to enter to learn about other systems which you have not studied, at least the frequency band. Okay. All right. Last but not the least, everything is done. I'm so happy we are almost done. Just two simple block diagrams. Okay. And we are done. Block diagram, a simple radio transmitter. First, I'm making a simple radio transmitter. Okay. First, you will make a box. This is one equipment known as the RF oscillator. Now, you know what is an oscillator? It is that device that will generate your carrier frequency. So RF oscillator means this is the place where your carrier frequency is generated. So whenever you're making this block diagram, also explain this to your examiners if they ask you to make the block diagram in the exam. Say, so, sir, the carrier frequency which I need to transport my intelligent signal is actually generated from this RF oscillator. Okay. This RF oscillator is sending data to the modulator directly. But the data is not enough because I also need the intelligence, right? So where am I feeding the intelligence from? That is the modulating signal. So you will say the modulating signal is also going to the modulator. So this shows the arrow and this symbol shows electronic circuits also. Arrow and electronic circuits, simple. You can use the symbol if you want. You can simply use an arrow and you can say my modulating signal goes from here. That is audio frequency. How does it go from here? You can say there is a microphone. Okay. Then you can make a, you can just say some person speaking, and this is converted into microphone, and then the microphone signal will go as a modulating signal in the modulator. Of course, there will be certain amplifier also here in between. If you want, you can add that amplifier also. Like this. Okay, if you cannot make a human, it's fine. If you cannot make a microphone, it's fine. At least modulating signal is enough. So what is important in your diagram? At least if you can make this, this, and this is enough. You send it to the modulator. From the modulator, it goes out, and it goes out in the antenna for transmission. Antenna is also known as aerial. A basic, simple transmitter block diagram. It's a very simple. That's why I'm teaching you this, because I don't want you all to miss out on this. From the antenna, it's transmitted out, radiated out. Simple. This is your simple radio transmitter. Second, do a simple radio receiver, and that receiver is by default called as a super heterodyne receiver. Okay, remember that I had that super word coming. That comes from here. Basic receiver, also called as super heterodyne receiver. So it is opposite to transmitter. The first thing that you will have will be an antenna. Okay, in your receiver, aerial or antenna. From the antenna, you are receiving the frequencies, you are sending the frequencies ahead. Okay. The radio frequency that you have received is going. So what you have received is the radio frequency along with the audio signal, of course. Okay. This radio frequency is sent to what is called as a mixer. Okay. This mixer is also fed with one more element known as local oscillator. This local oscillator will give another signal to the mixer so that the whole demodulation process can come. So we need to feed in one more signal. So the local oscillator will send that signal. LO in short. Good thing for you, you know, oscillator. That's it. Local oscillator means it's a random oscillator required to generate some random frequency required for our purposes in the mixer. So the RF will be mixed. The already achieved RF, which was high energy, is also again mixed with local oscillator generated frequency, probably to amplify it or increase its power or something, or to make up for whatever intelligence or strength was lost during propagation. Okay. Then the whole output from the mixer is fed, and something known as IF is fed. Now this IF is important in theoretical aspects when you're learning this concept in depth. For you, this is what they're looking for, to see if you know at least the introduction to these points. So IF stands for intermediate frequency. Then after the output of the mixer, and another frequency is added to the signal that you have received called the intermediate frequency. After this data, the intermediate frequency is then sent, or we can say that this frequency is also called as intermediate frequency. It's not yet ready to be sent out to the receiver, who is the human user or anyone who is the user. So this frequency can also be called as an intermediate frequency. So what is intermediate frequency? The RF combined with a frequency from local oscillator sent to mixer gives an output which is intermediate frequency. That output is sent to something that is known as detector. Now this detector is going to actually detect my intelligence now. So before the detector, everything was just making sure that the received signal, everything is strong. Okay. Then the detector will detect. Then the detector will detect the audio frequency and send the audio frequency for the output. And this is my OP, that is output. Now, generally, up to here, your diagram is fine, or else you can say, if it's a voice transmission, then the output is in the form of speakers. And here, I, as a pilot, can hear it. Like, of course, forget the face. Actually, I'm good with sketching, but I've lost practice. This is your output in speaker or digital output or whatever output you want. So you can add speaker. Otherwise, it's okay if you don't add speaker. But if you're making microphone and all for voice, then you can add speaker. Otherwise, this is your basic receiver diagram. Remember, in RT exam, too much depth is not required. Basic fundamental understanding is more than enough. Okay. Students who have their exams late or in the next session, make sure you take a good time to learn and revise this in real time. Students with whom I'm not gotten onto one-on-one yet, you also have to ensure I'm giving this one-on-one instruction right now in class collectively. Whatever we have learned till part 2, revise and be ready for the part 2 mock based upon all that I have said. That is the idea simultaneously for you to be ready, so that whenever we are doing mock, we only have to focus much on part 1, polishing and nothing else, because part 2, you're already prepared. I'll take a Viva and I'll just polish you if there is something less. So don't wait for my instructions to give you things. Just get started and get done thoroughly with part 2, and whatever your doubts you have, you discuss with me. Understand, if you clear part 1, many students do, but they don't clear part 2. Towards the end of the examination, you will not get time to do part 2. When the time part 1 or part 2, definitely. So it goes away from us basically. So we make sure we are prepared for part 2 well before we are going for the exams, and then towards the exam we can just finalize our part 1 thoroughly. So we are not worried about part 2. We are focused on part 1, and eventually we clear both the parts and clear our exams in our first attempt. Got it, students? So Ayush, Priyam, Pooja, Sajal, and Karan and Sahil, especially y'all. Then Jyotsna, she left. Whoever is giving the exams right now, be up to date thoroughly with part 2, all the 5 lectures that we have done today, tomorrow, revise and be ready thoroughly. That's it. Got it? You should not be waiting for that instruction ahead. Wherever you're stuck, let me know. And plus, not just for Delhi students, Hyderabad students can also do that. No problem. I would appreciate if you get ready along with Delhi students, at least for part 2, if you're not trained for part 1, or if part 1, part 2, both. So that you have no headache for Hyderabad exams. You can just practice, read, practice, make it easy. Keep it easy for yourself, right? Then you'll not have to attend RT lectures also ahead. Less number of lectures you will need to attend. You can focus on other ground subjects like that. Okay, students, any doubts? No? Thank you for being a nice class. Vishnu, take it easy. I'll get in touch with you. Okay? Be at ease. And I'll call you when I call you and we'll discuss. If you have any questions, drop me a message. And I'll keep that in mind. Anything urgent, I'll get back to you quickly, or else I'll get back to you nicely with some time. Anything else you need, let me know. Anything else, students, you all need, let me know. Everyone. Okay? I am really very happy to see your dedication, long lectures properly. You see how difficult it is for students before 11 a.m. to continue right now. See, 4 to 5 people are gone. So I appreciate it, students. Well done. Keep it up. Anything extra you need, it will be my responsibility to give. So just ask and I'll give. Okay? Keep it up. Be proud of yourselves. I'll meet you all on Monday. Same time. We'll continue a little more, brush up our part 2 things. Whatever is not covered, we'll do that, this, that. Wish you don't worry about all that. We already have a plan for you. Others, you can learn and you can do more preparation for part 2 along. And rest. Part 1 also, I'll reach out to you. And those who have exams sooner, please reach out to me first so that, you know, I'm reminded about that. That's all that I need from you, students. Going good. Sajal, good call. Vishnu, good call. Others, please practice calls. Priyam, you're doing good with your way you're learning. Others, please be more in touch with me with your preparations. Keep discussing over WhatsApp. How's it going? Pooja, you were doing it earlier, but now you're not doing it. So please get started. Nukul, you have not done it. Get started. Karan, Sahil, get started discussing that with me. All right? Chalo. Thank you, everyone. All the best. Be positive. I'll see you Monday.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Welcome,
Sir, have a
everyone.
nice day.
Wish you the same. Thank you.